Perfect. That sounds great.
Silence follows.
All right, good afternoon again, everyone. I'm Mike Toth, the Director of Research at Civitas, and I'm going to get us started with our first esteemed panel. We're going to be talking about the 2025 DOE report, and this is a report that was commissioned by the U.S. Department of Energy. We have a link to the report on the website and the conference materials. Commend everyone to take a look at the report if you haven't already. We've got four excellent panelists. I'll do the very brief introductions, which won't do justice to their incredible accomplishments. We've got Steve Koonin, who's the Edward Teller Senior Fellow at the Hoover Institution at Stanford University. We've got Ross McKittrick, who's a professor of economics at the University of Guelph in Canada. We've got John Christie, who's a climate scientist from the University of Alabama. And we've got Dr. Andrew Dessler, who's a professor of atmospheric sciences at Texas A&M. There it is. And the director of Texas's Center for Extreme Weather. And Andrew and I joked he brought extremely good weather today from the Center for Extreme Weather. This panel has a really innovative setup in terms of the presentation. So we're going to sort of do this as three different segments. So the format is going to be Dr. Christie is going to start by talking about extreme weather, and Dr. Dessler will provide a response, and then Dr. Koonin will talk about modeling, climate modeling. Dr. Dessler will provide a response, and then Dr. McKittrick will talk about economics and climate with a response from Dr. Dessler. All of that will take about 40 to 45 minutes, and then at that point we'll open it up to Q&A. So again, the point of this conference is really to make a dialogue. But for purposes of this panel, we just ask, we do want to do question and answer, but we ask to kind of hold it until the panelists have sort of worked through these three main topic areas from the DOE report. So without further ado, Dr. Christie, the floor is yours.
Thank you. And thank you all for coming out on this day. And we're going to talk about a section of the report I worked on quite a bit was extreme weather. And is it changing? Are the extremes in weather changing here in the continental United States? We call it the CONUS. And so this is the final version of our draft report that basically said there is no statistically significant changes in the extreme weather throughout the United States, whether you're talking about hot days in the United States compared to the earlier times, or storms, hurricanes, tornadoes, no long-term increases. Extreme precipitation events, don't see those persisting in terms of change throughout the country, and wildfires are not more common than they were in the past. What you will see here are actual data. I've got to emphasize that we built actual data sets to do this. So, for example, for the temperature in the United States, we looked at 1,211 stations across the country, all start in 1899 and all finish through 2025. And this is what, if you ask the question, when did record high summer temperatures or record low temperatures occur in the winter, you'll get this chart. And you can't get any other chart from the actual data. This is what you get. And you see the 30s dominate with a lot of high temperature records. And there's a bit there in the 50s, and in the early 2020s, there's also some. Low temperatures have gotten warmer through the years. And this is throughout the United States, we see less cold extremes. If you look at heat waves, this again is the only thing you can get from the actual data. We see the 1930s are very prominent in terms of heat waves, a bit there in the 1940s. It turns out that when you talk about dune activation events or dust storms, or dust bowls, I should say, we had two in the 20th century, only two, the 1930s and 1950s. The 19th century had 7 dune activation events. So these are common features of our climate, especially in the Great Plains. When you look at heavy precipitation events, we focused on 3 areas in the report because those were areas that had been claimed to have changes in precipitation. But we have 9 areas now that we're looking at. And precipitation is a strange metric, but here is one example. This is Kerrville, Texas. This is the actual form that the observer filled out. If you look at July 1900, you see there on the 15th of July, 11.6 inches in one day. That was the heaviest event that ever occurred in Kerrville. It is not in the official archives of the of the federal government because this form was never digitized. We digitized all these forms so that we have a consistent and serially complete record of events like this. In fact, if you look at this, you'll see a severe rainstorm occurred with the Guadalupe River rising 33 feet. You might recognize that number from what happened last July. Precipitation, as I said, is a very erratic metric. The blue lines are the heaviest two-day precipitation totals in Austin, Texas. And you will see that in 1921, 19 inches of rain fell in 2 days. The second place is about half that. So this metric is, let's say, extremely erratic and chaotic, and applying statistical analyses to these has to be done with great care, because you can get any kind of answer just by adding a few more years and finding a few more extreme events. So this is what we did for the 9 regions. These are time series of the actual amount of rainfall that fell in the heaviest 2 days. You'll see the top line is the Northeast, and there's kind of a rise up to about 2009, and then it has fallen back. That was due to an extra surge of tropical activity during about a 20-year period, but that's no longer there. The rest of the time series really don't have much of a change. And in fact, if you look at the Texas Hill Country time series, the black one there, the lowest amount of heavy rain events has occurred in the last 7 years. So just look at the bottom table here. These are some examples of a statistical significance on trends. The bottom table shows the heaviest 1% of days. When did they occur? And is it significant over the whole time series? And the answer is not significant over the whole time series. As you can see, the 1980s have no trends upward. There's one trend downward in the Southwest. That's what the SW means. But if you start in 1958, which is the favorite year for the national assessments, you can get some statistically significant trends. But if you start earlier or later, you don't. And so you got to be careful then about how you have your data set, where you start, where you end. Global hurricane frequency, there's nothing happening there. It's actually slightly downward. And hurricane events, landfalling in the United States have not really changed. There was a very quiet period about 20 years ago. For 11 years, no major hurricanes struck the country, which is also the same time that the Northeast had those extratropical cyclones. Tornadoes have been declining. Actually, major tornadoes have been declining. Droughts have not increased at all in the United States. We've gotten a little wetter, more moist. When you talk about global wildfire acreage burned, it's going down. And that's simply because people don't like their stuff to get burned up. They're stopping fires. In the United States, this chart is interesting. I wish we had time to talk about it. It's basically a 1,500-year chart of United States fires. And the fact we haven't had very many in the last 150 years from fire suppressions means we have a huge fire deficit. One little statistic to give you a clue about that is prior to European settlement, California saw 8 million acres a year burned. 8 million acres per year burned prior to European settlement. Today, the entire conterminous U.S. averages 8 million acres a year. So you can see that fire suppression is really a big story when it comes to global wildfires. And so I don't see anything in all the hundreds of comments I've read about the DOE report that would allow us to change this statement. Most types of extreme weather exhibit no statistically significant long-term trends over the available historical record. Thank you.
Okay, all right, thank you very much. So I'm going to respond to what Dr. Christie said. Let's start with extreme heat. So this is a plot that was in the rebuttal, which I was a member of. And it shows basically the same things that Dr. Christie's plot shows. It shows this is days above 105 Fahrenheit. I use that because it kind of shows it very clearly. But if you look at Dr. Christie's plots, it shows the same thing. It shows it's very hot in the 1930s. It shows it is, then we don't see a lot of heat in the middle of the 20th century. And then we see a lot of heat towards the end. I'm sorry, timer, so I don't go over time. And so the question is, what the hell is going on in the 1930s? Let's ask you guys, what's going on in the 1930s? You guys know this. Dust Bowl, I heard Dust Bowl, exactly. The Dust Bowl. Okay, now, we know, we've studied the Dust Bowl. It's not due to carbon dioxide. It's due to some internal variability, and it's due to some land use changes, what farmers were doing. It wasn't good, and it generated these very regionally local, very local high temperatures. Okay, so then, what's going on in the middle of the 20th century? Why is there no heat records there? Well, again, people have studied this. And it turns out that it's because of industrial agriculture. They started irrigating. And we know irrigation cools temperatures. So you have the Dust Bowl, and then you have irrigation. Those are both human. Humans contributed, but it's not carbon dioxide. And now, temperatures are going up again. Okay, we know it's not a Dust Bowl, because there's not a Dust Bowl going on right now. You guys know what it is. What is it? Greenhouse gases, exactly. We understand the physics of this. Now, if you listen to what Dr. Christie said, it's a very calibrated statement. We see no trend. And that is true. You don't see a trend, but you have to look at the physics of the problem. You cannot just do naive trend analysis. If you look at the physics, carbon dioxide is clearly driving up temperatures. We understand what's causing this. So carbon dioxide, greenhouse gases. And I'm not going to talk in too great detail. This only works if you look at the US. If you looked at a different region, they wouldn't have seen the high temperatures in the 1930s. The Dust Bowl is extremely regional. This is the same plot using the entire northern hemisphere mid-latitudes. The Dust Bowl gets averaged out when you do that. And you see clearly carbon dioxide. So cherry picking a region dominated by non-CHP. I'm going to list what I call the scientific felonies. These are things that would absolutely destroy this from peer review. If you submit this for peer review, it would come back to you spindled, folded, and mutilated. Okay, it would not make it through. They ignore the physics interpreting the data. You cannot take data and just put a line through it and say, voila. You actually have to look at the physics. This is a continuing problem with the DOE report. They never ask the question, why do these trends exist? And if you ask that question, you will get quite a different answer than the DOE climate report did. They omit contrary interpretations, and they don't talk about the existing literature. Again, if a graduate student brought me that, I would say, where's your literature review? Where do you why does the IPCC say, I don't know exactly what adjective, probably extremely likely that CO2 is increasing temperatures. Why are they wrong? We didn't talk about it, but Dr. Christie, he said something about using actual data. I think somebody asked him about it. We know the data he used, the USHCN data, has biases in it. They tend to warm the 1930s, cool present day. I think that's what he meant by that. It's a small effect, but just I would point that out. So lastly, this is truly a terrible argument. It is clear any rational evaluation of the physics and the data makes it clear climate change is making extreme heat more extreme. All right. And again, this is absolutely, their argument could absolutely never make it through peer review. All right, let's talk about hurricanes. So the DOE report makes the following argument. So they say there's no change in number of hurricanes. That is correct. And in fact, the scientific community has never predicted there would be an increase in the number of hurricanes. So this is a straw man saying, they're making a claim that doesn't contradict anything the scientific community says. Wind speeds are getting higher. They do say that, and that is true, and that is bad. So hurricanes are getting more intense. Through gritted teeth, they acknowledge that. And then in the very last section, in one sentence, they say, you can make an argument that rainfall should be getting more intense, but there's no evidence for it. I can't remember the exact words they say, but basically they say there's no evidence for that. And ditto for increased total flood depth. That's wrong, and that's wrong. And in fact, let me show you for rainfall. There's a lot of literature out there that shows that rain is getting more severe from hurricanes. And I'm not going to go over this, But I'll simply say none of this was referenced in the DOE climate report. And again, if you tried to peer review this, it would come back with like a footprint on it or something. That's what the reviewers think. I mean, you can't do this. You can't just say, oh, we don't know this, when there's a lot of peer-reviewed evidence that suggests rainfall is getting more intense and storm surge is also, or the total flood depth is going up because sea level's rising, and the same storm on a higher sea gives you more total flood depth. So let's look at what the IPC says. And notice that the DOE report cherry-picked, another cherry-picking, you see a lot of cherry-picking. They just talked about those things. Look at all the things they stopped talking, they didn't mention. Rapid intensification, that's likely. Latitude moving poleward, likely. Translation speed, likely slowing. Translation speed, those are very important. Rapid intensification, that is awful. Translation speed, that's how you get Hurricane Harvey. You have the storm roll over a city and just sit there. And they don't talk at all about the future. Now, we understand the physics of hurricanes. And we have high confidence they're going to get stronger in the future. Or the percentage will shift towards stronger. We have very high confidence they're going to produce more intense rainfall. Very high confidence they'll increase total flood depth. These are all bad things, okay? And they were just completely ignored by the DOE climate report. So cherry picking, focus on trends and number of TCs, a quantity nobody claims is changing. This is a straw man. It's just a waste of time. They acknowledge storms are getting more intense. Great. Some common ground. That's bad news, by the way. Factually wrong claims about rainfall and storm surge, and they ignore many of the other factors in physics that inform the future. And the bottom line is, and there's a strong consensus of this, climate change is making any hurricane that forms more destructive. All you need to know is that the sea's rising. Sea's rising, you're getting more flooding from storm surge, bad news, okay? All right, so let's go on to precipitation. All right, I'll get through this in 1 minute. So chapter 11.4, heavy precipitation, 11.4.2, observe trends. They conclude the frequency and intensity of heavy precipitation have likely increased on a global scale over a majority of land regions with good observational coverage. Now, if you look at 11.4.2, those are the papers they cite. It's 130 papers. It's a pretty short section, but they're citing all the literature. If you look at the DOE report, that's what they cite. And I'm going to flip back and forth. If you are keen, you will notice a difference. And again, the problem here is that they make no effort to engage with the scientific literature. I mean, why should we believe the one paper they cite over the 130 papers that come up with a different conclusion? Okay? Now, I asked my colleague, John Nielsen Gammon, Texas State climatologist, someone widely respected. Dr. Christie knows him. I predict Dr. Christie would even say he's an extremely reasonable guy. I asked him for an email comment. This is what he sent me. Chapter 6 summary. The sole sentence on extreme precipitation. Some increases in extreme precipitation events can be detected in some regions over short intervals, but the trends do not persist over long periods and at the regional scale. False. The statement appears to be based entirely on the work of McKittrick and Christie prior to and in the DOE report. As a general rule, because extreme precipitation is by definition rare, it is dominated by noise at the station scale. The regional results from the IPCC use thousands of stations, not the few dozen that McKittrick and Christie use. So the trends they detect are much more robust. My study, Jorgensen and Nielsen Gammon 2024, went back nearly as far as McKittrick and Christie for the South and Southeast, but used hundreds of stations. It was able to detect and quantify the upward trend in extreme precipitation. Works by Dan Wright and others have shown that an upward trend in extreme precipitation is detectable using large data sets over the central and eastern US. So, I mean, this is full of scientific felonies that would prevent it from ever making it through peer review. Very few stations, ignoring 100%, I'm rounding up from like 99.3, 100% of the previous literature. They provide no explanation of why all the previous literature is wrong. They ignore our physical understanding of, we understand physically why we should get more intense rain events. The 5-day metric, the IPCC usually uses a 1-day metric for mostly. And, the DOE report is just too weak to contradict the IPCC's conclusions. Thank you. Nice. Great.
Okay, I've been asked to address the issue, whoops, why are we back? No, we're back in Jones. There we go. To address the issue of how well are the models doing compared to observations, with a focus on temperatures and warming over the past 100 years. The models are important because they are the means by which we can project the climate changes induced by growing greenhouse gas concentrations. And I think it's important to realize that the models are really used to determine response. And what do I mean by that? You might see wonderful animations that are put together by NASA or NOAA of the climate system, and you see the jet stream and the clouds come and go with the days and the seasons, and they look really impressive. But that's not what we're interested in. We're interested in how the climate will change under human and other influences. Because I'm a physicist, I can't resist drawing a mass and a spring. And what we're interested in is not the unweighted position of the spring, the unperturbed climate system, but we're interested in how much will the spring stretch when we apply force to it. For the climate system, the force depends upon time. This is an IPCC graph. It shows the force upwards is warming, downwards is cooling. You see the greenhouse gases, mostly important are carbon dioxide, the pink line going up to the present. It starts in 1750, by the way. You see episodic coolings due to volcanic eruptions, the downward spikes, and you see a large amount of relatively slowly varying cooling due to aerosols and so on. It is the totality of these that are being applied to the climate system and that we have to understand the response. Doing that through the models has a number of problematic features. First of all, the forcings, the numbers shown here, are only about 1% of the natural flows of energy through the climate system. So this is a tiny tickling physically of the climate system. Of course, it might induce temperature rises that are enough to give us concern, 3-4 degrees worth of rise. But still, from a physics point of view, you're just tickling the system. We build these models by covering the Earth with boxes, typically 100 million boxes, and we move them through about 100 million time steps to describe some centuries worth of climate. And what you do when you do this is you discover that the world has about 50 different models put together by different groups. They disagree among themselves and they disagree with the data. There are various reasons for doing that. I'm not going to go through the details, but just to say, when people say models predict, you have to ask which model because they disagree with one another a lot. Let me show you some of that. This is a graph for 37 different climate models put together by groups around the world of how much would the global temperature go up if you doubled carbon dioxide. So this is a measure of the stiffness of the spring, if you like. And you can see that there's a factor of 3 from 1.8 degrees all the way up to 5.7 degrees variation among the models. The IPCC, using the models, but also various observational data, says that the best estimate is about 3, and a likely estimate is between 2.5 and 4. You can see that there are more than a few models that are well above the IPCC estimate and deemed to be just too sensitive to be plausible. That should give you pause. The best modelers making their best attempt, get it wrong, too sensitive about half the time. Let's see how it compares to the time history. This is the rate of warming from 1980 to 2024, so about 45 years of surface warming. How fast did the globe's surface warm? The individual red bars are the models, the different models. The yellow bar is the average of all of the models, and the blue bar is the observations. So again, models much too warm for the surface warming over the last 45 years or so. When you look at the time history, it gets even worse. The panel on the left shows the temperature change from the late 1880s up until more or less the present. The black curve is the observed warming, and the different traces are the different models. They're color-coded according to their sensitivity, the blue models being less sensitive, the brown model being more sensitive, and you can see it's pretty awful. The models do a terrible job individually of describing the variation of the global temperature over the last 140 years. If you focus in on just the last 40 years, as shown in the right panel there, it gets a little bit better, but it's also clear that there are some models that are just way too sensitive. When you try to segregate the models according to how sensitive they are, the first column is the low sensitive models, the middle column, the medium sensitive, the ones on the right are high sensitivity, and then going across in the rows, 4 different data sets. If you just focus on the lowest one, you get the point. You can see that it is the least sensitive models that do the best job of reproducing the historical observations of the temperature. So there's good reason to believe the climate is not as sensitive as the majority of the models predict. That was about surface temperatures. The models also fail in the upper atmosphere. Here in these graphs, the red are the different models, and the blue are the observations. Upper left panel, middle troposphere globally. Upper right panel, middle troposphere in the tropics, and similarly lower troposphere in the lower panels. The lesson to take away is twofold. One is the models are quite variable in what they predict. It's not just physics, because they give different answers. If it were just physics, it would give only one answer. And secondly, almost all of the models are inconsistent with the observations. If you go up into the lower stratosphere, here are 42 different models looking at the trend. The histogram shows the different trends over the last 25 years. And what's interesting is that the models all predict that the lower stratosphere should be cooling as it was from 1980 to 2000. But in fact, what the observations show is that for the last 25 years, the lower stratosphere has been warming. There is some fundamental misunderstanding at a level that matters in the models about how the atmosphere warms, and probably having to do with convection and clouds. Of course, the proponents of the consensus view will say this is just natural variability, and for the last 25 years, the climate's doing something that we didn't expect. But of course, they'll perfectly believe what happened from 1980 to 2000 and say, aha, the models are right. There's a lot of inconsistency in how people compare the models with the data. It's an even worse description of finer features. This is the trend of observed temperatures in the US Corn Belt, about 11 states, over 50 years. The red, again, are the different models. They have names, as shown on the bottom, and the blue is what's observed. This was criticized extensively in the paper that Andy and Rob Kopp put together. Here are some of the criticisms that they leveled. You guys selected a region where the models do worst. No, we selected a region that is agriculturally most important for US agriculture. Global analyses show that models do quite well at simulating the magnitude of historical warming, they said. No, don't change the topic. Okay? It's the regional trends we're talking about here. Explain why the models do poorly here, they urged us to do. Explain how this does not apply anywhere else on the globe. Again, do not change the topic. And is it unforced variability, as you say, or is it intensive agriculture, as you say elsewhere in the criticism? And then they say, finally, use a multidimensional ensemble approach that demonstrates the models do better if you include the uncertainties in the models. Well, if you do that, it broadens the uncertainty so much as to be almost essentially useless. Let me show you what they mean by that briefly, and then I'll wrap up. What's plotted here is a number of different models. On the horizontal axis is the global trend in temperature from 1981 to 2014. The gray band is what's observed, and the vertical axis is the sensitivity. And you can see that it is the least sensitive models that agree with the observations the best. And as the models get more sensitive, they give too large a trend. Well, what is urged by the critics of what we wrote is that any given model does not give just one answer. Depending upon how you set it up and you start it, you can get a whole range of answers as shown here. Those horizontal lines are the results for a single model run under different conditions. And so they say, you know, if you look up at one of these high sensitivity models, the fact that I can find one starting point that actually agrees with the data is enough to validate that data, that model. Of course, that doesn't sound right at all. In fact, they recommend at one point finding the least instance in each model and saying that makes all the models okay. I don't think that would pass peer review, at least among the peers I know. Let me close with a taxonomy of the kind of criticisms that are leveled in the report about models compared to others. Rarely do you see, although sometimes, the methodology that we used was incorrect. More commonly, they'll say, what you said is correct, but here's some omitted context. Here's a non sequitur, like I'll talk about global temperatures instead of regional. Your comparison interval is too small or too large, or your area is too small or large. Of course, the IPCC does this routinely. There's internal variability, as was said by, I think, Mark Twain. Statistics are the last refuge of fools and scoundrels. In this business, internal variability is the last such refuge. You need to include uncertainties, as we just explained, or here's why the model is wrong. They'll explain why it's wrong, but not disagree that it's wrong. The forcing's wrong, they'll say, or the data are wrong, finally, as you heard Andy say a few minutes ago. Or they'll say it's irrelevant, what you're saying. I'm just going to close with two quotes from primo climate modelers, Tim Palmer and Bjorn Stevens, writing in PNAS, a refereed report. For many key applications that require regional climate model output or for assessing large-scale changes from small-scale processes, for example, convection, the current generation of models is not fit for purpose. And then there was a paper in 2019, the use of climate models to guide local practical adaptation is unwarranted. Climate models are unable to represent future conditions at the degree of spatial, temporal, and probabilistic precision with which projections are often provided, which gives a false impression of confidence to users of climate change information. I can tell you I've got about 40 years of looking at sophisticated computer models to various applications, and climate modeling is not one of the better fields. And I think I'll leave it at that. Thanks for your attention. Andy.
Okay, so let's talk about climate models. This is a plot of Jim Hanson's 1988 prediction. The black lines are the models. The blue lines are the observations, an observational ensemble. And you see it agrees pretty well. And what you find is that climate models have a track record of getting the answer right. Now, it is true, that's true for CMIP 3 and CMIP 5. It is true that here's Exxon. Exxon basically had a spreadsheet. They got the temperature right. Predicting the future global temperature is not very hard. I can do it with 2 differential equations. If you want to predict the global average temperature, it's easy to do. It is true, though, that the last generation of models does have some models that run too hot. And so what Dr. Kuhn said was right. But what he said that's really unforgivable, I think, is he didn't talk about how this is well known in the scientific community. He's not, it's not the case that we're trying to bury this under the rug. The IPCC 6 Essential Report clearly discusses this. This is a paper in Science from my colleague Zeke Hausfather, and he clearly says, the models, we do have a set of models that's too hot. And they give a recipe for screening the model. So if you work on a problem that requires you to have the right climate sensitivity or requires you to have a good temperature, then then you can do it. So let me just kind of show you this. I sort of threw this together in the last few days. So this is all the models, same time period Dr. Kuhn showed, which is 1979 to 2023, 2024. And you see there is a difference. So the blue bars, it's a histogram. So the blue bars show that the models do on average, the horizontal blue line is the model average and the red line is the Berkeley Earth. There's a difference. But some of the models are too hot. We know that. So we can screen them. We can screen them following what the IPCC did, following what Hausfather said, and that's what you get. If you screen them for good ECS, you get the right answer, good climate sensitivity. You get the right answer. Now, the key thing to realize here is scientists are not idiots. Okay, if I'm doing a study that requires climate sensitivity to be accurate, I'm going to screen the models. If I'm doing a study that requires, I'm doing a study of ENSO, I'm going to use the models that have the best ENSO simulations. All right, scientists know what they're doing. So this idea that some of the models are wrong is irrelevant. It is irrelevant. He said that's what I'm going to say, and indeed I'm saying that. It is irrelevant. And I would sort of encourage him, maybe you guys can ask him, what's the implication on the debate of this? What result has come out from models being too sensitive that he thinks has misled the people? Now, let's talk about tropospheric warming. So this is a page shot from the DOE report. This region, the troposphere, the atmosphere, is an important test of climate models, since this is where the signal of anthropogenic greenhouse warming first and most strongly emerges first and most strongly. So that's wrong. That's just wrong. It shows a stunning lack of understanding of the atmosphere. It is not a fingerprint of greenhouse warming. It's just moist convective physics. ECS predicts too much warming. If future climate models were to realistically represent global tropospheric warming, they would likely be less sensitive than even the low ECS members of the CMIP 6 ensemble. That is wrong. Okay, that is absolutely wrong. The models do a good job reproducing the individual feedbacks. There's no reason to think that the models are getting anything about climate sensitivity wrong. I mean, the high models do look unrealistic, but the bulk of the models, especially the ones that are in the middle, look quite good. And there's no reason to think that if you fixed it, you would get lower than the low end. All right, that's made up. So now, let me say that again, what Dr. Kuhn said was right. There are disagreements between models and observations in the atmosphere. Again, this is well known. If you read what they said, they say the IPCC always points this out. But the thing you got wrong is the physics of this is extremely well understood. We understand what controls the atmospheric temperature versus the surface temperature. It's just convection, moist adiabatic physics. And the observed model difference has multiple explanations. Dr. Kuhn kind of tap danced around that. Oh, they'll say it's the observations. Yeah, it's the observations, or it could be the observations. Oh, he was very dismissive about maternal variability. There's actually research showing that. I'll show you a screenshot in a second. Those are literally quite relevant explanations. And again, if he tried to publish that, it would return folded, spindled, and mutilated, because they would say, you've got to talk about these other things. So let's talk a little bit about the observational biases. Satellite temperature record, Dr. Christie's record, has large non-climatic corrections that have had to be applied. Trend estimates are very sensitive to methodology. Published uncertainty estimates, as pointed out in our rebuttal, are often too small. The updates often shift the trends by amounts comparable to the state of uncertainty. And there's lots of papers that talk about the uncertainty. None of these were included in any discussion in the DOE report. Radiosondes, again, I'm not going to belabor this. The radiosondes where they launch balloons that hold thermometers, those are extremely hard to get trend data out of. Lots of possible errors in those. Again, here are all the papers not discussed in the DOE report. Reanalysis. I won't even go into what reanalysis is, but reanalysis are susceptible to drifts and discontinuities, not designed for long-term trend detection. Read the literature. And again, I mean, everybody has their own opinion about these things. And anybody can get up in front of a microphone and say whatever they want. And that's one of the problems with this debate. There's no rigor. There's no rigor to it the way there is in peer review. Again, try to get this argument through peer review. It would not fly. I understand Dr. Kuhn sounds very convincing. He sounds very sure of himself. His arguments are not good. He really poo-pooed internal variability. This is actually important. And it's not like we're just making it up. There is literally publications on this, not cited in the DOE report. I mean, I presume they've read the paper. Maybe they have, maybe they haven't. But this is a paper that came out, Pochedley, PNAS, Proceedings of the National Academy of Sciences, and they concluded that the forced response actually agrees quite well, in their analysis, agrees quite well with the models, but there's also unforced variability. I mean, again, they're not just saying it, they actually have an analysis that shows it. And I would encourage, if the DOE report has an analysis that shows it's not important, they show it. They don't have that. Okay, all they can do is try to poo-poo it. Oh, internal variability. That's what people who don't know the answer say. No, it's what the peer-reviewed science says. In addition, there's also a forcing bias from biomass burning that also tends to make the models trend to be too high. And in fact, this is a quote from it. Our results indicate that internal variability and forcing uncertainties largely explain differences in satellite versus model warming and are important considerations when evaluating climate models. That's science. The DOE report, not science. You can't just get up here and say, it's not important. And try to, cast aspersions. So let's go over the felonies. These are not misdemeanors. First of all, these are recognized problems. We understand how to screen models that are too sensitive. Again, scientists aren't idiots. It is true some models overpredict surface warming. Again, well known. It is true differences exist in atmospheric warming between the models and the observations. But the cause of this is unknown. You cannot say it's the models without showing me the work. They do not show the work. They have no work. They're just working backwards from a predetermined conclusion. And this is unlikely to be a major problem with models. We understand the physics. We understand the physics of atmospheric warming. The models should do a good job on this. All of our estimates suggest the models do a good job with this kind of thing. The DOE report is unacceptable. It contains errors and only discusses evidence supporting its preferred conclusion. It ignores all of the evidence that doesn't agree with it. And in fact, this is not, actually I won't go. I have a plot from Wally Broker showing in 1975 he was accurately estimating things. Anyway, I will stop here and turn this over to Dr. McGee.
Actually, I think mine is just sitting right here, so I'll just go off this version of it. Okay, I want to talk about the economics findings in our report. Specifically, I'm going to talk about U.S. agriculture, climate change and income, climate change and economic growth, and some comments on the social cost of carbon. Now, as a preface, I want to quote from the IPCC's fifth assessment report in 2014 in the economics chapter that concluded, for most economic sectors, the impact of climate change will be small relative to the impacts of other drivers. Changes in population, age, income, technology, relative prices, lifestyle, regulation, governance, and many other aspects of socioeconomic development will have an impact on the supply and demand of economic goods and services that is large relative to the impact of climate change. So it's important to understand the position, not just of the IPCC, but the economics profession over the decades that I've been studying this, is that climate change matters, it has effects, but over the long term, these are small relative to just about everything else that drives our standard of living. So talking about climate change in agriculture, there's a couple of different ways of modeling the effect. One is to relate land values to things like temperature and precipitation. And the more recent literature on that would say the warming is bad, that it has a negative effect on agricultural land values. Critics of that literature have said land values embeds too many things unrelated to climate. You should look at the rents paid for agricultural land. And if you focus on land rent models, the evidence is that warming on balance has been good for agriculture in the US. There's another approach using repeat land sale data, and that was originated in France. And the authors there found that warming has been very good for French agriculture. Using repeat land sale, you can factor out all the fixed effects that way. That study, I think, is relevant, but it would need to be replicated on US data to apply it here. Then there's an issue of whether US farmers are adapting to warming. So this was raised in Andy's report that we didn't talk about evidence that US farmers are not adapting as they should, as we would expect them to warming. So I talked to people in the crop insurance and the agricultural economics field. A difficulty there is the US government subsidizes crop insurance. Now it's about 60% of the premium is paid by the government. And that has severely worked against farmers engaging in adaptive behavior because they're becoming indifferent to crop failure. So that's an open question about how to get at that issue. Now, crop modeling is a little different. The econometric literature doesn't take account of the CO2 fertilization effect. So crop models can embed the effects of warming and precipitation change and CO2 fertilization. Generally, the results are that warming is bad, but CO2 fertilization is good. Precipitation doesn't really matter too much on a large scale. And a meta-analysis, a large-scale study in 2014 by Andy Challinor in the UK and his co-authors, their analysis was the effects broadly cancel out. The warming and the CO2 roughly cancel each other out. There would be a slight net gain in the simulations from their regression model. In 2017, a reanalysis of the same data set came to a very different conclusion, argued that the negative effects dominate, and that was a very influential study in the interagency working group. However, I was puzzled how you could use the same data set, come to completely different conclusions. So I got the data to try to replicate both sets of analysis and found that the Challinor data set left out about half of the CO2 data. And so I went back to the original sources, found as much of it as I could, put it back in, and then redid the Moore analysis, and their results end up lining up with the Challinor analysis after that. The CO2 and the warming effects roughly cancel each other out. Even as far as 5 degrees warming, you get an overall, essentially nothing much changes in net yields. There's a more recent study, Hultgren et al., which I won't go into, was brought up in the comments, because they also report extremely negative effects from climate change on agriculture. However, their main focus in all the tabulated results in their paper, they leave out the CO2 fertilization effect. So they're reporting the results just with warming and no CO2 fertilization. You have to dig way into the online supplement to find the combined effects. And once again, it comes out roughly as a wash. So I won't go into that study. Moving on to climate change and income, you could picture an inverted U-shaped relationship. If you have temperature on the horizontal axis and income on the vertical axis, the idea has long been there that there's an ideal temperature to live in. And then if you go colder than that, income goes down. If you go warmer than that, income goes down. So you have this inverted U-shape. And that would imply that warming will be beneficial in relatively cold places like Canada and relatively harmful in hot countries. And now that inverted U-shaped picture, it's hard to actually find it in the data, but it's a plausible picture.
And the empirical literature on this, it would then say that if you just shift the whole distribution of temperature up, you'll get a mix of positive and negative effects. And one of the authors that contributed to Andy's report, Richard Toll, has a recent survey of literature on this, and his summary was researchers disagree on the sign of the net impact, but agree on the order of magnitude. The welfare loss or gain caused by climate change is equivalent to the welfare loss caused by an income drop of at most 10%. A century of climate change is not worse than losing a decade of economic growth. It's not nothing. Canada's lost a decade of economic growth, but it wasn't temperature, it was bad government. But this is the chart that Toll has in his paper. And so Richard, in his comments, he objected to the chart that we used in our report and said we should have used his. So here's his, because it shows about the same thing. On the horizontal axis, you've got temperature. And on the vertical axis, you have percent change in global average real income. And these are econometric estimates as well as some modeling estimates. The heavy black line corresponds to about a 1 degree income loss per degree of warming. And that holds up to about 5 degrees. Now there is a range, and the more pessimistic results come from a certain type of study, the less pessimistic are from econometric and modeling papers, but the central estimate is still about 1% income loss per degree of warming up to 5C. It's a one-time effect. So the idea in this literature is a 1 degree of warming takes away 1% of income on average. And that's the kind of mechanism that's put into what are called integrated assessment models, DICE being the most famous of them. And they do show that you get a global loss of income due to warming, but it's relatively small or very small compared to the loss of trying to prevent the warming. And so the optimal policy generally involves only modest attempts at abatement. And otherwise you're adapting to the warming rather than trying to prevent it. The latest DICE model, another criticism of the economics chapter was we didn't discuss the latest version of the model in detail. Latest version of the model has a higher loss, 3.1% as of the year 2100, although that's not out of line with other modeling approaches. The thing to compare it to, though, is how much income growth is there by the end of the century? Well, the SSP scenarios that the IPCC is using, at the low end, you've got global real average income has doubled. At the high end, with the most warming, global average real income has grown by 16-fold. So even the poorest countries would be wealthier by 2100 than the US is today. So taking that 3% hit, it's off a much higher income level. It's not like 3% off today's income. Okay, when we look forward in time, we have to think about the processes of economic growth. There was an influential study in 2012 of Melissa Dell at Harvard and her co-authors who put a panel data set together and argued that warming affects the income growth rate too, not just income, but the growth rate. Now, they said it doesn't show up in rich countries, but there's a negative effect in poor countries. And then Moore and Diaz said, okay, if you plug that into an integrated assessment model, because of compounding, you now get a much higher social cost of carbon, a much heavier hit, and it justifies aggressive mitigation policy. So that study, it's been influential, but the subsequent debate hasn't held up that finding very well. So it was replicated on a different data set in 2015 by Burke et al., but then a subsequent reanalysis of the Burke data found or argued that it only shows up if you use a very specific functional form in the econometrics, but more generally, the result is insignificant, slightly positive, but statistically insignificant. Reanalysis of Dell, their own data, there's been a bunch of studies that have corrected some of the empirical deficiencies in their model, and the results disappear. And then on new and more detailed data sets, there's one by Zhao et al. 2018, and then I did one with a grad student that was published last year. And we find that warming has no effect or a slightly positive effect on growth, even in poor countries. And yes, that's my name on a peer-reviewed paper. We actually do publish. John and I publish all the time in peer-reviewed journals, and then we got criticized for citing our own work. So the social cost of carbon I won't go into it in too much detail, except to say it aggregates a lot of assumptions that are made at the modeling stage. So it's like a big if-then statement. It's aiming to give you a dollar value of the social damages of emitting a ton of CO2. Obviously, there are a lot of assumptions that have to be applied about the discount rate for the far future, climate sensitivity, assumed damage function shape, emission scenarios, even the assumption of what was the year that the climate was optimal. So the DICE model assumes that the year 1900 was the best climate the world has ever had, and the damage function is quadratic, whether you get cooling from that or warming from that. Why 1900? Well, it's an assumption. Uncertainties about all of those issues have to be resolved separately. The calculation of the social cost of carbon doesn't add any information to the debate over those assumptions. And so in the report, well, if I can give you a recipe for a high social cost of carbon, if that's what you want. But I would say that the assumptions that favor a moderate or a low social cost of carbon are the ones that are more secure. To summarize, while the world warmed over the past century, agricultural yields went up dramatically, income went up all around the world, except in a few places, and where it didn't go up, it wasn't because of climate, it was because of communism. And things like climate-related disasters plummeted to very low levels on a per capita basis. So going back to that IPCC quote about the future, that climate will have an impact on the future, but it's going to be small relative to all the other things that affect our standard of living. And I believe that that's been the case up until now, and the best evidence is that is going to continue to be the case into the future. Thank you. Oh.
I think I finally figured this out. Here. Yeah, that's good. Right, thanks. So to be clear, I'm not an economist. It's always hard to talk about things that are not in your wheelhouse. So I would just encourage you to read this chapter, to make the argument that understates climate risk, ignores risk uncertainty, tail outcomes, and the DOE report emphasizes low-end social cost of carbon estimates. And let me just show you one plot from this. So the red bars are the social cost of carbon estimates highlighted by the DOE. The blue bars are all of them. Now, I don't have a problem at all with self-citation. That's a standard academic thing. You cite yourself. But I do have a problem with ignoring other research, and that's really the problem here. This is Richard Toll. He emailed me, when he emailed me this, he said, I believe this is called cherry picking. And if you read their emails, which were released due to litigation, they have high regard for Richard Toll. His opinion is very high. And he actually, if you look at it, the bars have little cherries on it, which I think is adorable. This is not an honest evaluation of the social cost of carbon. It's their opinion, that's fine. But again, if you're writing an assessment, you have to include everything. Or you have to explain why you think those estimates are wrong. None of that is in the report. Now, Dr. McGinnis actually said this, and this is actually from the report. He says, 30 years later, virtually the identical point was made by the IPCC itself in the fifth assessment report. And he actually showed this quote: for most economic sectors, the impact of climate change will be small relative to the impacts of other drivers. And I thought, that's weird. That's the fifth IPCC assessment report. It says evidence since AR5 does not change its assessment. Well, if that's true, why do you not quote the sixth IPCC report? And I knew the answer because I've looked at the sixth IPCC report. In case you're wondering, anybody have a guess why he quotes the fifth and not the sixth?
Because the sixth didn't have a chapter written by economists.
All right, because the sixth doesn't agree with them. Look, that's fine. If you want to make an argument, the sixth is wrong, but you cannot skip it. You have to say, the sixth does not agree with me, and here's the reason why. Okay, look, people disagree in academics all the time. The thing you cannot do is simply ignore it and say, we're going to use this 15-year-old result, and we're not going to use this 3-year-old result. All right, you can't do that. Yeah, and I mean, if he had that, like, here's why we think it's not right. I mean, saying it's not written by an economist, I don't think that's a very good argument, but if they have a good technical argument, let's hear it. They didn't do that, okay? Recent global estimates of the economic cost of climate impacts exhibit significant spread and generally increase with global average temperature. The wide variation across disparate methodologies does not allow a robust range of damage estimates to be identified with confidence. Translation, we have no idea what the impacts of climate change are going to be. I mean, raise your hand if you think economists can predict how much economic growth we're going to have in the next 100 years. Raise your hand. You can raise your hand, Ross, if you think economists can predict global. I mean, I'm not raising my hand. I absolutely don't think economists have any clue about that. They simply can't do it. And I'm not here to bash economists. I'm just saying they have, unlike the climate models, which have a track record of correctly predicting the temperature, economists don't. And in fact, the economic models are made up. This is a very important point. This is a slide from Robert Pindick, who's a professor of economics at MIT. He was giving this in a talk. I screenshotted it and I asked it's reproduced here with his permission. Now, let's compare economic models to climate models. Climate models are based on the laws of physics: conservation of mass, conservation of momentum, conservation of energy, water thermodynamics. The physical system runs on rails, okay? And that's why we can predict the temperature in 100 years. There is no equivalent to economics. The economic models are made up. So the damage function, as he points out in the most popular model, as Dr. McKittrick said, the DICE model, it says loss goes as temperature squared. Why? He says no data, no theory. It's just made up. Why not temperature cubed? Why not temperature to the fourth? Why not e to the t? We don't know. And yet, Dr. McKittrick says this is good enough to bet the future of humanity. We have no idea. There is no academic credibility. I mean, these models are fine for what ifs, for sensitivity tests. They're not fit for purpose, quoting Dr. Kuhn.
No, that's Palmer and Stevens.
All right, okay, Palmer and Stevens, quoting them. These models are not fit for purpose. The models create a perception of knowledge and precision that is illusory and misleading. So Dr. McKittrick said it's only 3.1% reduction in GDP. What are the error bars on that? Plus and minus infinity, okay? Now I asked Richard Toll. You've heard a lot about Richard Toll. Richard Toll is Bjorn Lomborg's favorite economist. I did an event with Lomborg about 2 years ago, and it was like, Richard told this, Richard told that. He's the second most cited economist. Nordhaus was the first. So he's somebody that the skeptical side trusts. And I went on Mastodon and I said, the last IPCC report says there's no robust estimate of climate change's impacts on the economy. I was talking about my event with Lomborg. He says, who do I listen to if I want to know what economists agree on and where they don't? He said, there is, of course, no robust estimate of the impact of climate change on human welfare. You know about the range of estimates of future emissions, and you know about the range of response to the climate models, climate sensitivity. Then put the uncertainties about impacts and adaptation, future technologies, population, economic activities, add monetization of impacts, aggregate over people, time, probability. We don't know what the economic impacts. And I find it just maddening that Dr. Kuhn got up here and criticized climate models, models that run on the laws of physics. Models have a track record of getting things right. They're not perfect. And then Dr. McKittrick gets up here and says, let's bet the future of humanity on economic models. Models that are made up, that have no error bars. We have no idea what the maximum is. Now, they might be able to make an argument about that, but they didn't, okay? Let's talk about what William Nordhaus, Bill Nordhaus, Nobel Prize winner. I have used the metaphor that climate change is like a vast casino. We are rolling the climatic dice. The outcome will produce surprises, and some of them are likely to be perilous. The message is that we need not roll the climate dice. There's time to turn around and walk back out the casino. That is not what they're telling us. They're telling us to roll the dice on humanity. He further says, technological change raised humans out of Stone Age living standards. Climate change threatens, in the most extreme scenarios, to return us economically whence we came. Again, we don't know. I'm not saying it's going to happen. What I'm saying is they can't say it's not going to happen. Their numbers are fiction, all right? And that's what all the economists know. I could write an economic model. Give me 20 minutes with Excel spreadsheet. I'll give you a model. But the question is the model any good? And you talk to economists, they run their models, and most will say, yeah, but of course, we don't we don't know if these numbers are good. They're good for other things. They're not good for actual predictions that you can set policy on. So again, the felonies in this section are large: cherry picking, social cost of carbon, misrepresentations, omission of contrary data. And again, I can't tell you how maddening it is that they get up here and insult insult, they're not humans, but they cast doubt on climate models, physical models, and turn around and say, but these economic models are perfect. Okay? No, do not buy into that. That is not correct. All right, so, and I asked, again, Richard Toll, climate economists, does any economist think that economic model estimates are good enough? They should guide our policy response. He says, no, they're not good enough for that. Estimates of the marginal cost of the first and second best climate policy vary by 2 or 3 orders of magnitude. Credible published estimates of the social cost of carbon vary by 3 or 12 orders of magnitude. He goes and say, I think you should interpret cost-benefit analysis of climate policy differently. Almost everyone agrees the optimal policy starts slowly and then accelerates. No one agrees on the rate of acceleration. Almost everyone agrees 100% emissions reduction is hard to justify. I'm not going to get into that. But the point is, this entire thing about economics is just fantasy. It's fantasy. Okay, we have no idea how bad climate change is going to be. Absolutely not. All right, let me summarize. I'm going to sort of summarize my 3 talks. The DOE is not a credible scientific document. It could not survive peer review. It violates most, if not every, norm of science. There may be some norm of science it doesn't violate if you think hard enough. It is a political document designed to support rolling back of the danger finding. We know that from the emails that were released. It was produced by a DOE process that was corrupt. They violated laws, they violated acts. It was not peer reviewed. The writing group was set up, designed to get a particular response. And the other thing about it is, if you ask about climate skeptics, these guys are the gold standard. This is it. These are the best climate skeptics in the world. And if the DOE report is the best they can do, then the red team, blue team exercise has reached its conclusion. There is nothing in climate skepticism. These guys are the best. Their report is awful. It violates every norm of science. It ignores, their arguments just don't hang together. So in that sense, the report was a success. It actually demonstrated that there is nothing to climate skepticism. Climate science is robust. It's probably, in fact, the most robust science in the history of humanity because of the economic consequences. Anyway, I would be, look forward to the conversation. So I guess we'll answer questions. I think some people, I won't point fingers, went over time. Maybe it's me.
Sure. We just have a few minutes for questions, but I was going to kind of follow the lead here from before. There was a question teed up to Steve about the relevancy point. So Steve, why don't you start with that? And then we've got time for a couple questions. So as you're answering that, Steve, if there's questions, please put your hand up and we can call on folks. But
So the question, if I remember right, is what was the practical import of having 40% of the climate models being too sensitive? And your statement, Andy, that it was well known in the scientific community, indeed, true. But what matters is not the knowledge in the scientific community. What matters is the knowledge among the public, in particular, the decision makers. The presence of hot models allowed people to exaggerate the impacts, alleged impacts, or possible impacts of greenhouse gases. The scientific community failed people like you, Andy, and people even more credentialed than you. Did not stand up and say, no, that's not correct. The climate crisis was exaggerated with the consequence that society ran down a rabbit hole of rapid decarbonization, deindustrialization of countries, rapid increases in electricity prices and degradation of the grid, scaring the bejesus out of young people about an impending climate catastrophe, and retarding the energy access and hence economic growth of more than half of the world. So yes, scientific honesty has consequences, Andy, and the climate community has failed to accurately represent the situation. The DOE report attempts to right that injustice.
Yeah, no, I mean, that's bullshit. Sorry. I said I wasn't.
Andy,
I wasn't going
you know,
to-
you're a
I
tenured
was not going
professor
to
at one of the
profanity.
world's better universities. You should not be using the words like felony or bullshit.
Well, I'm sorry, but it is what it is. Look, the idea, the IPCC clearly talks about hot models. Articles are written about hot models. What Dr. Coonan is saying is just this fantasy conspiracy theory about how people have been misled. I mean, you know, the people who are being misled are the people who read the DOE report. That's misleading. It is not. I mean, I can't. I mean, what more can we do? It's in the IPCC report. People write it. Everybody you talk to knows about it. I mean, it's just, you know, are there people who exaggerate? Sure. That's not the scientific community's fault. That is not the fault. I mean, the DOE report is far more egregiously misleading than anything in the scientific community has said. You know, and I'm sorry, it is a scientific felony. What you guys did in that report violates every norm. There's no peer review. The way you omitted evidence, you know that would not make it through peer review. You know a grad student turned that into you. You would tell him to go back to his
Andy,
desk.
you just gave a 5-minute disquisition on economic impacts, right? One piece of evidence that you omitted is that since 1900 until now, humans have flourished like never before, even as the globe warmed by 1.3 degrees, about the same amount of warming that the IPCC expects in the next 100 years.
Steve,
I think that is evidence, not persuasive, but evidence not to be ignored, that humanity will see a minimal economic impact of the warming that's projected.
Yeah, I mean, that's a ridiculous argument. Look, correlate, you probably know
I did not make an
correlation
argument, I
does
just
not
offered
imply
a piece of
causality.
evidence.
Okay. Look, correlation does not imply causality. Why are humans?
Why do you think the pattern will change?
Look, let me finish this. Why are people healthier today? It's because of the invention of antibiotics. It's because we have satellites flying. So 1900, a big hurricane hit Galveston, 8,000 people died. What would happen if that same hurricane hit Galveston today? Well, we have satellites, we'd see them, they would evacuate. It's not that because the Earth's warming and warming is better, it's because we would see it coming out 5 days in advance and people would evacuate. The city would still get absolutely crushed. So, but I mean, this idea that there's a correlation between well-being and temperature is just, that's just the worst. That's the worst argument. I mean, it's evidence, it's so weak, so weak.
I didn't make.
You just made that argument. You said
No, I
it's a
didn't
piece
say
of
there was a
evidence.
correlation. I said despite the warming,
Well.
humanity has prospered. Andy, precision of thinking is real important.
Look, precision of thinking, I agree. An event like this, it's hard to do. This is why
No, it's not.
This
No,
is
it's
why
not.
stuff like this should be done in writing. Not, you know, these public events are places with no rigor. People can say anything. So that's why you peer review your stuff. And I guess I would ask you guys, you know, the DOE process was incredibly corrupt. Why did you agree to do that? Why did you not insist on other authors? Why do you not insist on peer review?
We did insist on peer review. We went through an internal peer review and then we wrote it knowing it would go up for public comment. The peer review process was shut down by the environmental groups. We're still waiting for the opportunity to put out our responses to all the peer review comments. It's not our fault that we had to sit and wait for a lawsuit
It
to
is
be
not peer
completed.
review. There was an email from Travis Fisher to you guys saying, do not call this peer review. This is not peer
No.
review.
He said the internal
Gents,
review
we'll
should be
wrap it up
called
with
an
this.
internal review.
That's right. It's an internal review. It's not peer review. Anyway, sorry.
Thank you for the spirited discussion to the panelists here. I think a round of applause is in order. We didn't have a chance to get to audience Q&A, but if the panelists are able to stick around for a little bit, we've got a little break now for about 15 minutes, and I welcome everyone to continue the conversation. Thanks.
Seats and start the next panel, please. Welcome everybody to the second panel of our conference, which will focus on the legal policy surrounding climate change, with an initial focus on the suits that are being brought in states and localities about climate change. I really enjoyed the last panel, but because it seems like the panelists in this conference like to argue a lot, we decided to subject you now to a panel of lawyers, where you're going to see some true professional disputation occur now, with all the rhetorical flourishes, which has only started to emerge in the first panel. Now we're going to have people who just disagree for a living. So I'm really glad we could put together a balanced panel with different views, just like the first panel on these issues. And I hope we'll have plenty of time for questions and answers, because I think these lawsuits open up the issue about how should we, under our system of governance, approach questions of climate change, regardless of how you came out after listening to the first panel. Which branch of government, which level of government is the appropriate place to regulate these issues? So we're going to start with Jonathan Adler, who's in the middle, who for many years was a professor at Case Western and really one of the country's leading scholars of environmental law, and then just recently moved to become the Cabell and Taylor professors. Somehow they wanted him so bad they gave him 2 endowed chairs, which should be illegal, I think, in most of it. But he has 2 endowed chairs at William and Mary. He just started there this last year. And then at the end of the panel, he'll be followed by Todd Zawicki, who is university professor at George Mason, which is their most distinguished chair, right, throughout the university. And he's going to speak. And then right next to me will be Mike Toth, who's the director of research here at the Civitas Institute, former Marine JAG officer, former general counsel of a company. So he's the only person on this panel who actually knows about the practice of law, and is also written, both litigated and written on these climate change cases. So Jonathan, why don't you take it away?
Great. Thank you. It's a pleasure to be here. Fun to be here on February 5th. It's the 55th anniversary of the Apollo 14 moonwalk is today. And for those who celebrate it, it's also the NBA trade deadline. I think there's about an hour left or so. But last I heard, Giannis is not moving. But in terms of our topic on climate litigation, what I wanted to do as an initial matter is put some of this climate litigation in a context in terms of the history of environmental law as a way of understanding it as a broader phenomenon, and then to say a little bit about some of the legal issues at the larger level, not in terms of the substance of the suits themselves, but the legal issues about whether or not suits like this should be allowed to proceed. And then they'll probably say some things about why I'm wrong, and then we'll have a fun discussion. So as we all know, there's over the last decade, there has been a rash of suits filed by state and local governments, with one exception, all in state court under state law, and we'll get to why those two things matter, seeking compensation from fossil fuel companies under various tort theories for the costs imposed on state and local governments by climate change. And these are mostly kind of adaptation costs or disaster response costs, things of that nature. And that's where, at least in the United States, the bulk of serious non-administrative law or non-regulatory climate litigation is. That is to say, there's obviously litigation with the federal government over regulations that agencies are adopting or rescinding and so on. And that litigation is always very serious and worth focusing on. And then there are a lot of other suits that are out there that are really kind of symbolic exercises, or things that are about generating press coverage or 60 Minutes appearances, but aren't actually about achieving anything in the courts of law as opposed to the courts of public opinion. And those sorts of suits are things like the kids' climate cases, right, which generate lots of fawning press coverage, but legally are quite bonkers and have no real anchoring in existing doctrine. Now, in terms of thinking about how climate litigation relates to environmental law more broadly, I think it's important to think about the history of environmental law. And we tend to talk as if environmental law kind of emerges in the 1970s. When, we have the first Earth Day, and Congress enacts all these various federal statutes, and that's the birth of environmental law. But that's actually not the birth of environmental law. The environmental law, as we should really think about it, goes back to at least the 17th century. And it wasn't obviously Congress. It was individuals, landowners, communities seeking to use courts to protect persons and property from the other uses of property that might cause them harm. So the first reported case that we know of is a case called William Aldred's case, and it's a scenario that we could imagine, right? There's a landowner and his neighbor is raising hogs, and the landowner doesn't like the smells and odors and waste generated by his neighbor, and so he sues in nuisance. And as you might expect, and this is again something we're quite used to, the hog farmer's response is, hey, wait a second. I'm producing food for the community. I'm generating economic value. You know, don't have so sensitive a nose because I'm doing something that's really valuable. And the court says, well, you know, that may all be true, but as a matter of law, the issue is what the rights are, not some net welfare calculation. And every landowner has the right to use their property in a way that does not interfere with or prevent their neighbors from making equivalent use of their property. So raise all the hogs you want, but don't do it in a way that effectively ousts somebody from their home. And so the sic udere principle, which we see in nuisance as the foundation of nuisance law, traces back at least as far as that case. There's some reason to believe you can actually go a few hundred years earlier than that. In the Anglo-American legal tradition, in the early history of the United States, that environmental law is primarily things like nuisance actions, trespass actions, one landowner perhaps suing another landowner for making a land modification that causes flooding or things like that. And the idea that there were remedies like that was well understood. And once the Constitution is ratified, we see this also across state lines, mostly in the Supreme Court's original jurisdiction, but downwind or downstream states litigating against upwind or upstream states over things occurring within those states that cause them harm. In the progressive era, the smoke control movement, the movement that ultimately leads to the first burst of air pollution legislation, is actually initially a nuisance movement, a movement seeking to file nuisance actions against coal factories or other facilities burning coal in cities to force them to either change their behavior or to move outside of town where they would not pose the same risk to neighboring landowners. Now, over time, we begin to see legislation adopted, initially at the state and local level first, well before it gets adopted at the national level. In fact, both air pollution and water pollution levels were declining before the federal government enacts its 1970s legislation, something that we often forget. And it was done for a variety of reasons, including the fact that we thought that having clear rules that were predictable, that were understandable, that were applied consistently might be better than rolling the dice on litigation and figuring out who could sue who, where, and when. And so that's why we saw at the state and local level, we saw legislation initially supplementing common law nuisance actions and the like, and eventually in some cases supplanting it. And that's also what we see when we move to the federal level. The federal legislation in part also having the aim of tamping down on variable state legislation. What's interesting in this area, especially in the context of air pollution and what ultimately leads to things related to the Clean Air Act and greenhouse gas emissions, is that when Congress enacts its legislation, such as the 1970 Clean Air Act, it expressly says that it is not preempting state law that aims to control the pollutants that Congress is going to control. The language that we often use is that Congress was enacting a floor, not a ceiling, and states and localities would still be free to do more than what Congress required. We can argue as a matter of political economy whether that's the way federal statutes actually work in practice. That is to say, sometimes creating a floor can actually act as a de facto ceiling, but as a legal matter, in terms of what states are legally allowed to do, when we look at the pollution control statutes, we see relatively little preemption in those statutes, and we see that explicitly by choice. That is to say, the Clean Air Act, Clean Water Act, and the like have savings clauses that expressly say, we're leaving everything alone. And the few exceptions tend to be things like product standards, where there was a specific concern about the ability to sell products in national markets. So, for example, the most prominent exception in the Clean Air Act is the preemption of variable state standards for automobiles, which was done because not because states were going to do too little, but because there was a fear in Congress that states were going to do too much. That once California adopted vehicle standards in the 1960s, that other states were going to follow suit, and the automakers didn't like that. Now, something else that happens after the federal government enacts its statutes is that the Supreme Court concludes that it would prefer not to have these cases come before it, and not to have to hear cases in original jurisdiction of a downwind or a downstream jurisdiction suing an upstream or an upwind jurisdiction. And so the Supreme Court announces that under Erie, and we can get into Erie if we want later on, that's for the true legal nerds among us. The Supreme Court decides that these cases, insofar as they rely upon federal common law is displaced. Because the choice of federal law for dealing with pollution problems is that which is provided by statute, not that which is would be provided by the federal common law. But it's important to recognize that what the Supreme Court says explicitly is that this is displacement, this is not preemption. This is a choice of law rule, this is not a voiding or rendering inoperative rule. The idea under Erie is that federal common law is disfavored, and anytime Congress gives us an excuse to rely on a statute as opposed to federal common law, we should take it. The Supreme Court says that's going to be the rule for interstate pollution, but then says explicitly that that suits can still be brought under state law for transboundary pollution, provided that at least if it's nuisance litigation, that the law of the source state is applied as opposed to the law of the downstream or the polluted state, and that's essentially a way to prevent opportunistic behavior. And in a case called International Paper versus Ouellette, the Supreme Court affirms that. This was folks in Ouellette were suing International Paper for cross-boundary pollution, and that suit goes forward under state law. International Paper ultimately settles that case for both air and water pollution for a substantial amount of money after it's remanded from the Supreme Court. Why do I give all this history? Well, because the climate change cases are being brought against greenhouse gases, emissions that are, as a consequence of the Massachusetts versus EPA decision, subject to regulation under the Clean Air Act. That I'm one of those who thinks that decision was wrong, but that opinion and $3 will get you an overpriced coffee drink. The Supreme Court has concluded otherwise, and the claim has been made, and the Trump administration makes the claim, and fossil fuel company defendants have made the claim that because greenhouse gases are regulated under the Clean Air Act, these sorts of suits should not be able to be filed. The problem, of course, is that while these suits under federal common law would be displaced, as the Supreme Court held in a case called American Electric Power versus Connecticut, under International Paper and the other relevant precedents, they are not preempted and they can proceed under state law. Now, this does not mean the cases are sound. It does not mean the tort theories deserve to win. It does not mean the juries can or should find in favor of it. It doesn't even mean necessarily that these cases are consistent with the state laws under which they're being filed. All it means is that there's no legal basis at the front end to say that these cases are preempted and have to go away now. And that's currently the legal battle we're in. And why do we say that? Well, because for something to be preempted of this nature, it requires Congress to actually preempt it. As Justice Gorsuch put it in a recent case, courts are hardly free to extend a federal statute to a sphere Congress was well aware of, but chose to leave alone. Congress was aware of the long history of using tort law and nuisance law as the primary mechanism and source of redress for pollution, including for transboundary pollution. It chose to leave that alone, and unless and until Congress revisits that choice, these cases are going to be and should be with us and will bounce around unless until they either peter out on their own, they are settled, or Congress decides to legislate. Thank you.
It's great to be here in Austin because it brings back a memory of when I was clerking on the Fifth Circuit for Jerry Smith a few years ago, more than a few years ago. But we actually had a sitting here in Austin where we sat with the brand new minted judge at that point, Judge Benavides, and then the legendary E. Grady Jolly from Mississippi. And we had this case where this lawyer was making an argument. I don't remember the details of the case, but the argument was essentially went like this, which is if you read this statute in this particular kind of way, and you read the case law in this way, and the exception in this way, and the facts of this way, we clearly win the case. And so it goes on and on and on. And finally, Judge Jolly leans forward and says, counsel, you do realize that the biggest obstacle to you winning this case is the complete absurdity of your argument. The point being that when a law or a legal doctrine sounds absurd, it probably is, and it's highly unlikely that over the long run, the courts are going to adopt this. So I'm not going to quibble with Jonathan's description of maybe what the best reading the law is. We can have that debate separate. Maybe that is the best reading law. What I am going to say, though, is it's not the only reading of the law. I think there's another reading that is, I think, at least as plausible, but certainly plausible, and it actually comes out with a result that makes sense and doesn't lead us down this absurd path. So, and this isn't for Jonathan. I'm not doubting his legal acumen and how he's parsing the case law. Let me make that clear. I just think there's another way of reading all this that's much more plausible, that courts are much more likely in the real world to grown-up courts, at least, are to apply. So let's apply the Grady-Jolly test to think about where this particular reading might lead us. And where does it lead us? So let's focus on the Colorado case in Boulder, right? I spent a semester in Colorado as a professor at University of Colorado. And, Boulder's exactly what you think it is. It's a hippie town full of very wealthy hippies who basically live in a utopian community where they think food comes from the grocery store and energy just falls from the sky. I think we saw how sort of policymaking is made in Colorado recently. If you followed the recent power outages, which are not outages, but basically the power company in Colorado shut in the middle of a very cold spell, shut off the power for 4 days to everybody's houses, right? Because a few years ago, there had been all these fires. The energy company was held liable for it, even though it's not clear that they actually caused it, but they were held liable for it. And so because there were high winds and it was very dry. So it's very cold, it's very dry, they had high winds. They shut down in the middle of a sub-zero, several day cold front, all the electricity in Boulder. Now, why did that matter? Well, because Boulder, in their magical thinking, had basically said, we're going to get rid of all gas stoves. We're going to get rid of all gas power, right? So basically, you had people sitting in the cold. They couldn't start their cars, right? Because they all had electric cars, right? And this is the world in which these people occupy, right? And these are the people now. This is the county that has decided to bring this lawsuit. Now, one of the things I find amusing about this lawsuit is we always hear climate change is an existential threat to the world. The biggest thing they seem to be focused on in Boulder, from what I could tell, is it will cost more for us to maintain the roads now because of the rain and frost that'll come with it, which I think is pretty amusing, right? But think about this. If Boulder can do this, Austin can do this, Falls Church City can do this, San Francisco can do this. Basically, anybody anywhere can bring one of these cockamamie lawsuits under this. And some of these lawsuits, I mean, Jonathan just brushed over them. I think there's one now, I don't know if you've heard about this one in Oregon, which is basically climate murder. Have you heard of this one? Somebody suing now for wrongful death because of somebody died supposedly because of heat in Oregon caused by this, right? I mean, we're talking about these crazy things, right? But, it's pretty clear this could unleash literally any community in America could sue any of these companies. But why stop the power companies? Why not sue airlines, right? Fossil fuel companies, airlines, anybody who emits it, you could blame them, right? But why stop at fossil fuels? We all know every form of energy creates some sort of externality. Solar panels, wind power, right? We all know more than I ever thought we would know about the psychological health of whales related to wind power. Why not, right? Why don't we just sue all of this, right? Airlines, trucks, anything that you could do, right? And I would say there is a pretty big difference. Maybe you disagree, but I would say it's a difference in kind, not just degree, between some guy who wants to run a pigsty in a residential neighborhood and the ability to re-engineer the entire American economy and society with all the implications that go along with trying to manufacture energy policy through some judge in Colorado in state court, right? These are complicated sort of trade-offs, and I just don't think it makes any sense to think that the common law or any judge thinks that this makes sense, right? I mean, we're talking about, as we heard on the last panel, we're talking about energy, which has been, along with the rule of law, I would say, probably the single greatest thing that has lifted billions of people out of poverty around the world. I heard a fascinating speech by Maguette Wade from Africa a few years ago, who talks about what it's like to be poor in Africa without access to low-cost energy. She says, basically, women in Africa spend hours every day basically collecting wood to be able to heat up water so that they can cook, they can bathe, and do all those sorts of things, right? According to the World Health Organization, I couldn't find a really credible organization, so I had to rely on the WHO. But according to the World Health Organization, that there are 2 billion people in the world who rely on indoor cooking fires, which is they yak dung, they burn dung, they burn wood. It's estimated about 3 million people around the world die prematurely every year because they have to do indoor cooking, because they have to burn these sorts of effluents in their house, especially kids, right? This is really, in my view, vicious, anti-human policies. I mean, it's just unimaginable to me that Tom Steyer is flying around on his jet thinking that this is a way to improve the world by doing this sort of stuff. Before petroleum, we also had externalities, right? As you probably know, New York City used to run with horse crap every time it rained. Do you know why brownstones are walk-ups in New York? Because the rich people could actually afford to elevate their houses off the street so that they didn't get so much horse crap when it rained, and the poor people couldn't. All those forests in New England are all new growth forests. Why? Because that all used to be farms where they would grow hay to feed the horses in New York, Boston, Providence, and in places like that, right? We're talking about complex trade-offs that just are not possible to be made by random judges who aren't taking into account all these sorts of things. Now, fortunately, it turns out we don't have to go on the Jolly test and to take the absurd reading. I think the dissent in the Colorado case provides a perfectly plausible and certainly, I think, more reasonable reading of what all this is. Basically, what they said is you don't ask whether the Clean Air Act preempted state lawsuits. You ask whether the Clean Air Act authorizes state tort lawsuits. Now, why do they say that? Because prior to the Clean Air Act, there was no state tort law, right? Prior to the Clean Air Act, they say these were primarily a matter of federal common law because this was a uniquely federal interest to deal with these sorts of interstate type things. And so I'll just quote a couple money paragraphs. Had Boulder state law claims been raised prior to the Clean Air Act's enactment, they would have been precluded under federal common law. And simply because federal common law related to greenhouse gas emissions has been displaced by statute doesn't mean that the conditions that made state law inappropriate to govern these claims in the past have vanished into thin air. In other words, Congress's decision to displace federal common law and take control of this area did not suddenly render state law competent to regulate interstate and international air pollution. Nothing in the Clean Air Act reflects that Congress intended the result the majority reaches here. Unlike the blue fairy that brought Pinocchio to life, the Clean Air Act did not magically breathe life into state law tort claims that had been lifeless as a wooden puppet, right? Now, they go through the history. Again, I'm not going to argue right here. It's the only reading of the history, but it sure as heck is a more plausible reading of what Congress enacted. The idea that Congress in 1955 and 1970 all of a sudden passed a completely comprehensive regulatory structure, and then, without ever mentioning it, said, and then the states can come along, or then private billionaires could come along and fund litigation to allow states to just re-engineer, state judges to re-engineer the entire economy. And there's no evidence in the Clean Air Act to suggest that that's what they were doing, creating this duplicative, massive type system. And so it seems to me, if we apply the Jolly test and we apply standard methods of legal analysis, it seems obvious to me that what we're talking about here is not a sustainable system. If it is, then I would encourage anybody to start bringing lawsuits against solar panel manufacturers, against windmills, against everything the green people love. And if you can figure out a way to do your own consumer fraud claims against people like Tom Steyer and the groups that are pushing this idea of existential threat that we have to sacrifice millions of people to poverty and early death because of the possibility of global warming, that sounds like fraud to me. So I would say if you can't beat them, join them. Thanks.
Wonderful. Not surprisingly, with four attorneys on the panel, you're going to get 5 different opinions on the matter. So I'll sort of pick up, I guess, where Professor Zwicky left off on kind of the legal issues or the legal defects that I see with the municipal climate cases. Not so much with the earlier part of what Professor Zwicky talked about, though I will note it's not simply a matter of one subjective view as to the quality of these cases. And I think Professor Adler did a nice job when he touched on this earlier in his remarks. But the reality is, in state courts, these cases have been on a losing streak. And so just in the past 18 months in Pennsylvania, in Maryland, in New Jersey, in Charleston, South Carolina, these cases have been found to be not viable. And I think some of the tenor of the state court judges, not necessarily on the issues that we're going to be talking about during this panel, but the state court judges, I think, have sort of had the same kind of mental block that Professor Zwicky pointed out earlier in his talk of, you're asking us to do way too much here at the state court level. So I do want to make that point, but I want to pivot more importantly, which is what we're all focused on, which I see to be the legal defects of these current cases. And I'm just going to say 3. First and foremost, the case that Professor Adler talked about as being a viable case under the Willett decision of 1987 does not exist. There is no case that's pending that is a Willett case from 1987, and I'll touch on that for a couple minutes. So primarily, if we look at the cases that are pending, the municipal cases that are pending, they're different in a very substantial way from the Willett case. That case isn't one of the cases that we're going to talk about. So that's first and foremost. Secondly, if you look at the municipal climate cases, there's a structural constitutional problem. John referred to it earlier, in that the cases are seeking state courts to essentially make foreign policy. I'll get to that as point 2. And then point 3 is some of what Professor Zwicky touched on in terms of the Clean Air Act. Though you don't have to quote a dissent, it's a very good dissent, and I agree with you, the dissent from the Colorado case is worth reading, whether you agree with it or not. Actually, a 9-0 Supreme Court decision from Justice Ginsburg, the AEP case, actually distills the history of the Clean Air Act in a way that I think is dispositive on the matter. So 3 reasons. First is the case are not a Willett case. Second, the global issue. And then third and final is sort of the Supreme Court precedent interpreting the Clean Air Act. First and foremost, on the Willett case, just so we're clear, the Willett case was a case where the U.S. Supreme Court resolved that class action of residents of Vermont could sue the International Paper Company, but only under New York law, because New York was the state that had given the permit to the International Paper Company. And therefore, the state law that applied from the Supreme Court's perspective was New York law. And the Supreme Court specifically said they could not bring a lawsuit under Vermont law. If you look at the two cases that are pending, the Colorado case as well as the Hawaii case, they're not trying to apply Texas law to Texas emissions. They're not trying to apply Nigerian law to Nigerian emissions. They're not trying to apply West Virginia law to West Virginia emissions. They're doing exactly what the Supreme Court in Willett said you can't do. They're seeking the court to apply Hawaii law to emissions in 49 other states and 190 countries around the world, which is precisely what the Supreme Court said you cannot do. Now, the US Supreme Court, apart from a very tiny handful of cases, is a court of appellate jurisdiction. It's not a court of original jurisdiction, which is to say it can't rewrite it can only take an appeal based on the case that is actually pled, right? And so the cases that are actually pled, that are live, are not Willett cases. They're precisely different from Willett cases. And just an additional point on this, I think that really makes it abundantly clear, is there was one potential Willett case that was brought by the climate groups that have been supportive of the Hawaii case, which is pending, as well as the Colorado cases and the other ones that have not gone their way, which was a Delaware state court case. And in the Delaware state court case, as with the others, the plaintiffs wanted to apply Delaware law to emissions in every country of the world, right? Delaware law to every other state of the United States, and also Delaware law to emissions in the state of Delaware. The court dismissed the application or attempted application of Delaware law to the out-of-state and international emissions, but said you can continue to plead this case and take on Delaware emissions under Delaware law. And the plaintiff said, no, we don't want that. So the plaintiffs are primarily interested in applying their own state law to emissions outside of the state, which is, again, not the Willett fact pattern. And I think that's very important. I'll give one very practical reason. If you think about the company in the Willett case, they got a permit from the state of New York, which was pursuant to the Clean Water Act. If that company felt like the permit wasn't the right permit for the kind of emissions they wanted to do, in the ordinary course of things, they could talk to the regulators of the state. They could get a different permit, right? And if they didn't like what the regulators were telling them in terms of what the regulators were willing to permit, they could go to another state. They could leave New York and find a different state that may give them a permit so they could move their business, hire their employees, provide the services and the goods that they're providing to the economy. If you don't do what the Supreme Court allows under Willett, and you do what the Supreme Court specifically prohibited under Willett, you get a situation where it's like Hotel California, and you can never check out, right? So if Hawaii law applies to you, as long as there's personal jurisdiction, some minimal contact, you could have no business in Hawaii, you could have no sales in Hawaii, you could purposely decide, I don't want to do business here because I can't comply with the regulatory climate, I'll go somewhere else. But you're still subject to Hawaii law, right? And that's a major horizontal federalism problem. It's putting Hawaii in charge of national policy, right? So that's why it's a very important problem in terms of the difference between the case that doesn't exist and the Willett case. My first point, second point, just second and third point, very briefly, because we do want to get to questions. On the global point, oftentimes I think attorneys, when they talk about these cases, they go right from, the fact that these are seeking to apply one state law to the other 49 states. They go right to that point. But these cases are about global emissions. And I know there's a lot of individuals who have studied the oil and gas industry or in the oil and gas industry. Are most emissions inside the United States or outside the United States? Right? Overwhelmingly outside the United States. Close to 90%, according to the International Energy Agency, close to 90% of emissions are international. And actually the trend is towards international, not towards national. If you go back to the year 2000, the US made up about a quarter. Now it's closer to 10%. The developing world, due to the global surge in energy demand, is seeking more energy, more emissions, right? If you look at some of the companies that have been sued, this is just public documents. If you look at Shell's website, company reports, they provide their products to over 30 million customers. over 30 million customers in 70 different countries. They report that upwards of 80% of their emissions are from outside the United States, et cetera, and so forth. So, as Willie Sutton said, right, why don't we rob banks? That's where the money is. The money in these cases is outside the United States, right? So what we're fundamentally doing in these cases, 80, 90% of the prospective liability is we're asking a state court to affect our foreign policy, right? We are, our energy exports to Europe increased 3 times after a liquid natural gas after the Russian invasion of the Ukraine. Now we're going to have a state court judge who's going to make energy products more expensive, right? It's going to affect that foreign policy. Our energy exports to developing countries is increasing. We're going to have a state court judge who's going to interfere with that, right? So there's a long list of Supreme Court cases where the Supreme Court has said, issues that touch on federal affairs are the province of the federal government, not of the state court, not of the state government, and certainly not of state courts. And they've said that in cases where there's a lot less interference with foreign relations and international affairs than what we're seeing here. And again, like John, you said earlier, wherever one falls in terms of the first panelist who presented, there is a fundamental question about what level of government. And I think everything from the Clear Air Act to the Supreme Court cases really points to the executive branch, the political branches, making these kinds of very important decisions with regard to our international partners. And then finally, just on the Supreme Court case, as I mentioned before, Justice Ginsburg in the AEP case, really points out that the standard for looking at interstate emissions is federal law. It's federal common law. Federal common law means that there is not state law that's operating. There's a quote from Milwaukee 1, which is a Supreme Court decision from before the Ginsburg opinion. When we deal with air and water and their ambient or interstate aspects, right? That's what we're talking about with greenhouse gas. There is federal common law, Milwaukee 2. Federal common law exists. It's because state law cannot be used. And Ruth Bader Ginsburg, in the opinion from the court, unanimous court, says environmental protection is in the national scope. The court says in particular at the end of the opinion, and I think this is a very important point, at the end of the opinion in AEP, the court says, okay, well, there's one issue that we're not deciding. Well, what precisely does Justice Ginsburg say that they're not deciding? The relief under state law, in particular, the law of each state where the defendants operate the power plants. In other words, in the source state, right? So Justice Ginsburg in that last issue, in that last paragraph, simply says that the only thing that state law might be able to do is what happened in the Willett case, which is to use state law to focus on the state law of the source state to focus on emissions there, which is, again, not what we have in any of the municipal climate cases, all of which that are live are seeking to apply the state law of the forum to emissions all around the country and all around the world, which is precisely what the court in Willett and then again in AEP said can't happen, and it creates these structural problems with the Constitution, et cetera, and so forth. So I think there's numerous reasons why the cases are not ultimately going to be successful in the state court system.
Great. So let me start off question and answer by turning to Jonathan, who might also want to use this time to reply to some of the responses to his presentation. So Jonathan, I wanted to know what you think the optimal arrangement for government decision of these questions were to be if you were in charge. So your presentation, I believe, was this is the way it is because of Supreme Court precedents. And I think right, Todd and Mike said, well, the law is arguably one way or the other, but the optimal way to decide this would be have a uniform federal policy. I couldn't tell from your presentation whether you agree or disagree. And then I think their secondary point was these causes of action at the state level are almost frivolous. It sounded like the idea that energy companies have a right to have to disclose climate change harms to everyone who buys oil and gas assumes that people don't know, right? That these harms are already included when you buy petroleum products. So I wanted to hear from you what your normative view is, rather your descriptive view.
So my normative view of the suits as a matter of tort laws, I'm very skeptical of them, both because of the type of attribution that has to be shown. I mean, so for example, an oral argument in the Seventh Circuit, I guess just 2 weeks ago, the plaintiffs acknowledge that for their consumer fraud claim to work, they have to show the climate impacts from the quantum of emissions, the marginal quantum of emissions that are a consequence of the consumer misrepresentation as a percentage of overall emissions, and then what those effects are in Illinois in the relevant time frame. And my read of the, not a scientist, but my read of the attribution literature is that would be a really heavy lift. But generally, when it comes to tort law, we let plaintiffs try and make their case, and if the attribution can be shown, it can be shown. In terms of at a policy level, if it were up to me, I would tell Congress, because that's where legislation comes from, not the executive, not the judiciary, to eliminate the stationary source provisions of the Clean Air Act's applicability to greenhouse gases, to preclude most of these suits for most of their effects, and to impose a revenue-neutral carbon tax and call it a day. If it were me, that's what I would do. I think that makes much more sense. The idea that courts can engage in that kind of judgment, I find to be the sort of thing that's just alien to our legal system. That is just not what judges, if litigation is allowing people to produce outcomes that from a policy standpoint we think is unwise or wasteful, legislatures retain the ability to preclude that. And the history of environmental law is filled with that, where we decide litigation is either producing restricting private economic activity too much, or it's too variable, or it's too uncertain, or it's not protective enough of people and their properties. But that's a legislative choice. If we didn't have that, I happen to think the displacement doctrine that Milwaukee 2 invents and that American Electric Power is based upon is ahistorical and was made up. And there is nothing in the history of the Clean Air Act that suggests that Congress thought it was displacing anything. There is nothing in the original understanding of Article 3 that suggests Congress was displacing anything. It's a holdover of the Erie Revolution. And I think one of the more unfortunate aspects of it, the reality is that prior to that period of time, it wouldn't have even been federal common law. It would have been understood as the general law of nuisance applies across state lines, and those cases could be heard in the Supreme Court's original jurisdiction, as many were, or they could be heard in state courts or federal courts if federal courts were created. But we're a long way from that. But so I agree, as a practical matter, you want to deal with an environmental problem at the level where that environmental problem manifests itself. And if our current institutional structure isn't doing that, then we have proper ways of making that happen. And that's Congress going through bicameralism and presentment to enact a law, not trying to make these arguments for what are essentially preemption by penumbra, where we argue, well, we should be able to dismiss the case now because we think later on, when the court has to resolve the choice of law question in response to a motion on that issue by the defendants, or when the court is considering the damages, they might get the quantum wrong and they might award damages for things that weren't properly within that court's jurisdiction because it's a state court. Those are all interesting questions, but we don't resolve them at the front end of litigation. Those sorts of things aren't the basis for a motion to dismiss. Those are the basis for appeals to challenge the verdict. And so I understand those concerns about litigation. I think they're real concerns. They just have no place at the front end to try and preclude the plaintiffs from having any opportunity to bring them at all. That's why every federal circuit court that has heard the claim that these cases can only be brought and understood or cognizant under federal common law has rejected the claim. And these haven't been by crazy liberal judges. These are opinions by people like Stephanos Bibas of the Third Circuit or Professor Zawicki's former colleague Naomi Rao on the DC Circuit. They make it quite clear for these things to be preempted, Congress has to have preempted it. Justice Ginsburg also says that at the end of the American Electric Power case. She says state law cases are to be preempted. It's a function of the Clean Air Act and the statute. That's what Ouellette says. The permits were irrelevant in Ouellette. That's not a defense in a nuisance case in most jurisdictions. That is why on remand, when it went back to court to hear it under New York law, international paper settled for both air pollution and water pollution that it was causing to the folks in Vermont because it knew it had to answer for those claims. And so I think that the Colorado courts may think they're incompetent to hear, or Justice of the Colorado Supreme Court may think Colorado courts are incompetent to hear these sorts of claims. As a matter of Colorado law, might be perfectly correct. But as a matter of federal law, both as the way we originally understood courts to operate under Article 3 and state courts, which were the dominant courts, because right under Article 3, we don't have to have any lower federal courts. The original public meaning of Article 3 only requires a Supreme Court. It presumed that things could be brought in state court. Under that and under Supreme Court precedent, the plaintiffs get to take their shot. Again, I think it's a bad shot. I think it's a policy matter. It's a crazy way to try and deal with climate change. But that's not something, courts should not be resolving the, quote, complicated trade-offs that Professor Sawicki mentioned. They should be resolving claims based on the rights that people have. And if legislatures don't like that, legislatures can fix it.
Let me put the question to Todd and Mike in a way that is your question in your response, but maybe for people who aren't, didn't have to go through 3 years of law school might understand, which is basically what I read Jonathan's response is what's wrong with just the regular way we make policy? Why don't we just use that for, the regular way we make policy is generally the states regulate everything unless the federal government chooses to act in those specialized areas, which are within federal jurisdiction. Here, Jonathan says Congress has not acted. And so the general presumption we have in all law is we let the states regulate. And why don't you trust the states? We have a system of federalism where, we're in Texas right now, which has very different policies on the environment than California, where unfortunately I'm still rooted. Because of that, I pay different income tax. I have different environmental. Why don't we allow competition and policy variability that we apply for everything from the death penalty, right, to euthanasia and on and on? Why don't we use that for the environment too? That's Jonathan's challenge, I think, to both of you is what's wrong with the regular way we make policy for these kinds of lawsuits and these kinds of questions?
Yeah, because this is exactly not that situation, right? This is Boulder, Colorado, claiming to make policy for the entire country, right? It's not a zoning decision in Berkeley that has no impact on Texas.
We don't have zoning anymore.
You don't?
Actually.
Oh, well,
no,
good,
because
good.
that stood in the way of multi-family apartment buildings.
Good point, right? But there are things that are local, and that's what federalism is, right? This is the quintessential example of one state trying to control policy and outcomes in other states. States with very diverse populations, people with different preferences, people with different socioeconomic status, right? All these policies, like more expensive energy is highly regressive. I don't know if you know that, right? Older people drive older cars, they live further from work. It's not linear in terms of how much it costs to, cook a plate of, a pot of spaghetti or heat your house or run your water heater, right? We've got those sorts of questions. We've got different priorities that different states have. And so this is the quintessential situation in which we understand the traditional federalism doesn't work because fundamentally what they are doing is not regulating anything in Boulder. They're regulating the entire rest of the country to force everybody else in the country to subsidize the hippie effete sort of fantasies of Boulder people. That's classic example where we don't trust federalism. And that's a classic example of why we've always had this situation, which we do have federal common law to deal with the situations where we do see these overlaps, or we do see these externalities, or we do try to see people regulating activity in other states, and we don't trust a particular state's law or a particular state's court, especially elected judges, to be able to buy votes by basically catering to the people in their own states while imposing the cost on everybody else around the country to basically subsidize the things they're doing. And so to the larger point, why don't we just let it play out? Yeah, these cases seem frivolous. They always seem frivolous until they're not, right? It only takes one judge. That crazy kids case in Montana, that was frivolous until they won, right? What we have here is the situation in which the entire rest of the American people have to rely on Exxon and these guys to win every single case, right? One case and it's over. everything else gets form shopped into that jurisdiction, one after another after another. And this is what they did in the tobacco litigation. The plaintiffs' lawyers got together. They filed exactly this same lawsuit in 10 states. They lost in 9. They won in 1 and form shopped everything into that, right? This is why it can't be the case we just let these cases run on and on and on, while guys like Tom Steyer and these other billionaires basically get their jollies by funding these environmental groups to just engage in endless litigation, endless theories and we all understand litigation, the process is the punishment. I mean, millions of dollars. Basically, they've got unlimited funds. They've got unlimited billionaires who will fund these fantasy lawsuits where just the cost of defending these by the energy companies means higher energy prices, less money for exploration, less money for innovation, all the things that we need. Simply the litigation, the millions of dollars of litigation costs that they're imposing on the rest of us affects our quality of life. And so I think this is a classic situation where where people need to understand, even if this is frivolous litigation, they don't care. The process is the punishment. They'll just keep bringing these cases over and over and over, and they'll find, deep-pocketed people like who will continue to fund these situations. And just that process itself is making all the rest of us poor.
Yeah, and I would just add to that, as I said earlier, 80 to 90% of emissions are international. And so what we're asking state courts to do is to set international policy. And there is a litany of U.S. Supreme Court cases that I think we can all appreciate that says state courts, their province is not to make international policies, it's not to deal with international relations, it's not to deal with foreign relations. Those powers belong to the federal government. There's a lot of people who would want the state of Texas making international policy. There's a lot of people who would want the state of California making international policy. What we have in the Constitution is a federal government to make international policy subject to elections every 4 years, right? And so there's major structural problems with the way these cases have been pled, and it's incumbent upon the parties bringing the cases to try to keep the cases alive and get them so that they can actually be adjudicated. And they haven't done that. That's the first point that I mentioned earlier, which is, again, if we look at Willett, if we look at this narrow gap that the Supreme Court left open, it was to bring cases under the law of where the emissions are happening. And there's not a single case that has been brought that has tried to do that. They've done the exact opposite. They're trying to apply the law of Hawaii or Colorado to emissions that are happening outside of the state and outside of the country, right? Which is precisely what Willett said that you can't do. And so they're not viable cases under existing precedent, right? So, what's incumbent upon parties that bring cases is to know the law and then conform to the law to the best you can to advance the case. And that hasn't even remotely, we're not even remotely close to that happening in these cases.
So we have about a little over 20 minutes left. So I'll invite questions from the audience. Before I do, I should have made 2 disclosures. One reason we're talking about this is the Supreme Court currently has pending on its docket this exact case, and it's trying to decide right now whether it will hear there have been cases out of Maryland, Colorado, Hawaii, they're all over. One of those cases, the Supreme Court denied cert last year, decided not to hear the case, but right now, at this very moment, they're deciding whether they're going to hear these cases. The second, I should have made clear, personally, I filed an amicus brief that the Supreme Court should hear that case with my podcast co-host, Richard Epstein. So if any of you know Richard Epstein, it's not a question of whether you're going to file a brief at the Supreme Court. It's a question of whether you can stop Richard Epstein from filing a brief at the Supreme Court. And so we filed a brief. I mean, I think he's one of the great tort scholars of our time. And he has very strong view. Again, when does Richard not have strong views? He has very strong views about the tort case. So we decided to throw an amicus brief in together saying the Supreme Court at least step in and resolve these issues one way or the other. So let me take questions. Steve.
So in the last couple of years, the issue of climate change and mitigation has declined in salience, certainly in the popular discussion, and to a large extent in the political discussion. One might be tempted to blame the present administration for that, but in fact it's international, and there are fundamental reasons why it should be happening. Do you think that the fact shift will affect the prevalence or success of the cases? I know the law is supposed to be above politics, but my sense is the reality is not that. So,
So the question, if I, is just, do you think the public's interest or the political salience of climate change, global warming, whatever you want to call it, is going to affect maybe the Supreme Court's decision whether to intervene or the way the lower courts are answering these questions?
I mean, my view is, yeah, I don't, I mean, one thing that's interesting is these cases, unlike some earlier cases, which AEP was representative of, which sought injunctive relief, sought orders to actually require emitters to emit less. These are about damages. So these are arguably about adaptation, not mitigation. So in that sense, that's also an interesting shift that the litigation has moved in that way. As I mentioned earlier, we still have things like the kids' climate cases, but those are PR cases. Those aren't, as a legal matter, those aren't serious. It shouldn't affect the court. I don't, does it affect whether the court will grant the case? It might. I mean, my own view of this is that the current court doesn't like preemption. It doesn't like the Dormant Commerce Clause, which would be another way to try and make these cases go away without statutory preemption. But if California is allowed to effectively set pig treatment standards for the country, it's not clear that the Dormant Commerce Clause under current law is going to do much work there. The court, even when it takes tort cases that it feels it has to, it doesn't have a lot of enthusiasm for them. Last term, it took 2 securities law tort cases and then digged them after argument. That's the court basically saying, yeah, we thought we were going to resolve these cases, but they're too messy and we're just going to, never mind. We'll take a mulligan on having heard the case. So insofar as these cases, and the court recognizes these cases present messy questions about litigation at the front end of that litigation, I think the court is going to be reluctant to take them. I think that's why it's denied cert in all of the federal removal cases, petitions that have been filed, and I think there were 6 or 7 of those, and it's denied cert in the Honolulu case and the prior cases. The argument on the other side is there is arguably a circuit split because there was a case in New York where the plaintiffs did some silly things that got them in front of the Second Circuit on a posture that wasn't great. And then the Second Circuit wrote, just as a matter of history and like factually recounting the structure of our government, a horribly wrong opinion. But that gives enough of a circuit split that if the court wants to take it, they might. But I don't think they like the idea of being the entity that decides when tort litigation is a good or a bad idea. I think they like the idea that if Congress thinks these cases are bad, they should do, for example, what they did with the gun industry, right? So Congress enacted I always get the name of the statute wrong, the Protection of Lawful Commerce in Arms Act. Why? Because creative nonprofits and plaintiffs' lawyers were bankrolled by rich billionaires to file lots of lawsuits to try and bankrupt gun manufacturers. And Congress figured the process was a punishment. Congress did what Congress is supposed to do, which enact legislation and say, let's make these cases go away. The Supreme Court just heard a case last term shutting the door on an attempt to get around that statute. I think that the court prefers that. If the court thinks that Congress just can't get its act together, maybe it'll think it has to intervene. But that's my take on it.
Todd, does the Supreme Court read the newspaper headlines too, just like everybody else? And will it affect their decision on whether to intervene in these cases?
Yeah, I think so. I mean, I think in Jonathan or Michael may know, maybe Jonathan sees like this, but there is a fundamental issue here, which is when I read the briefs by these plaintiffs, they just have made no effort to respond to this feeding frenzy problem, right? This pig pile problem of everybody in the world every municipality, everybody cooking up some lawsuit with just redundant litigation over and over and over and over and over and over and over, right? And then cooking up these various different things and basically filing 1 and then 10 and then 100 and then 1,000 of these cookie cutter lawsuits in different jurisdictions and the like. And if they can't come up with some plausible explanation for why we're not going to have this feeding frenzy, it just strikes me that Supreme Court can't be that dumb, right? It just can't be that they leave that door open to that. And so if they come up with some plausible way of doing that, which as far as I know, maybe Jonathan see, but as far as I know, they haven't. I don't think they will because they want to be able to do that. They need to do it. I think it's been pretty clear that the cost of this become more apparent, right? You know, basically Europe destroying its own economy and helping our manufacturing base with their idiotic policies. That's why Europe doesn't want it. It's pretty clear we don't want it. I do think one of the problems, and Jonathan mentioned briefly, and I want to elaborate on something he said, was that EPA versus Massachusetts case was a really bad decision that I think is kind of a clunker in the middle of this, where they have this sort of whole coherent idea of major question doctrines and stuff. And so in EPA versus Brown and Williamson, for example, the court said, the Congress has known for a long time about tobacco, and they chose not to regulate it. The FDI can't regulate it. EPA versus Mass seems to be exactly the opposite, which they said people for a long time been wanting to do this. Congress has chosen not to do this, and so we need to make them do it, essentially, right? And that one case is kind of a clunker in all this. And so how this might fit with those questions about the major question doctrine, what Congress intended with the Clean Air Act, and a lot of this background we've been talking about, I think might be part of this as well.
Okay, good. Steve Hayward?
I was going to ask a question about it. And I know it's a distinct question, maybe the inverse of what cases in front of us. So you kind of answered the question already as an outlier. So I'll just go to the second part, which is, you think the current court, if the question could be presented again, would overturn it since it was a collateral case?
If people couldn't hear that, Steve asking, do you detect any kind of interest on the Supreme Court to overturn Massachusetts versus EPA? For those who don't follow this closely, Massachusetts versus EPA was a case where the Supreme Court said under the, I hate saying the name of the statute, the Clean Air Act, under the Clean Air Act, the EPA must regulate greenhouse gases. not say the word Clean Air Act, but whether there was like a statutory obligation in a way for the EPA to set some kind of regulation for greenhouse gases. As you may know, before this decision, the EPA chose not to.
Right.
Yeah.
They won't. They won't overturn it because it's a statutory decision. So generally, statutory stare decisis is the strongest form of stare decisis. The idea being that if the court misreads a statute, Congress is fully capable of changing it. There are other things about Mass versus EPA that the court has either already cut back on. So in a case called UARG, it basically said we're gonna confine the damage. In that case, at oral argument, Chief Justice Roberts actually asks UARG's attorney, "You're not asking us to overturn Mass versus EPA, are you? Because we don't do that." He says that at argument. UARG can kind of confine the damage in that respect. The standing decision of Mass versus EPA, right? So the question of what does a litigant have to show to get into court, in particular a court, into federal court under a federal statute, that the court might revisit, right? Because that's a constitutional question. And the court, I think, is very unhappy with current standing doctrine and the fact that it has led to a proliferation of lots of types of litigation that the court thinks should go away. But the underlying Mass versus EPA holding, I don't think they'll overturn it. Last thing I'll note, though, if they overturn it, then AEP versus Connecticut goes with it. Because AEP versus Connecticut is based upon greenhouse gases being subject to regulation under the Clean Air Act. And if you take that away in Mass versus EPA, well, then federal common law for greenhouse gases is back, and we don't even have to talk about state law.
Yeah, my sense is that they've kind of treated Massachusetts EPA as kind of an embarrassment. At least when I read these major question doctrines case, they kind of pretend like it doesn't even exist. They hardly mention it. They don't even try to distinguish it. They're just kind of going to leave it there, nip it away, keep it as narrow as it is, and just pretend like they never really did that. Is my impression. But it does. I was just sort of yeah. So.
Well, I think I'll just say one thing on top of it all. I agree with the sort of prediction on Mass v. EPA. If Mass v. EPA is still the law, and we have a situation, and this kind of gets to Steve Koonen's question from before, where a state court, whether Colorado or Hawaii actually tries one of these cases, I think at that point you will see an appeal to the Supreme Court, and the Supreme Court, if there is a finding of liability at the state level, will reverse it. And the reason why the Supreme Court will reverse it, and I appreciate Professor Zwiecki's comment on the sort of preemption point in terms of the justices, but I think fundamentally it's not a preemption case, right? I mean, if you look at the sort of analytical thrust of what I see in the Ginsburg opinion from AAP, she makes the point very clear: the baseline, the framework for interstate, international emissions is federal, right? That is the baseline, and then the Clean Air Act provides further detail on top of it, right? So it's not a matter of preemption where you have a state law that a federal law knocks out. You didn't have the state law to begin with, which is how Ginsburg structures a unanimous opinion for the Supreme Court. So I think if there is a finding of liability, I think the court will then take the case. And then, Steve, I think your points about the world around us really become important, right? The trend is towards more international emissions, right? So we would have a state court basically regulating more and more and more of what's going on outside the United States. You've got, obviously when the Russian tanks rolled into the Ukraine, that was an inflection point. That was 2022. That's before the current administration. That changed the world's views on international energy markets, on international energy production. That changed Europe's views on those matters. That changed international finance's view on that matter. The more that the U.S. Supreme Court sees state courts dominating national affairs, I think the clearer it becomes this is a problem that they're going to address.
Right over here.
I mean, there are clean hands defenses that the defendants could raise, but they're not waiting for the opportunity to raise them, right? So there are various legal doctrines that make it hard for you to seek redress from somebody that's doing the same conduct that you're doing, right? So there's this equitable notion of kind of like reciprocity. There are all sorts of defenses like that can be raised in the context of these cases, including defenses also about right? So all the defendants are present in the jurisdictions where they're being sued and have activities in the jurisdictions they're being sued. And some of the conduct for which they're being sued for is that the plaintiffs, when they file their complaints and file their lawsuits, the way plaintiffs always do, leave as many options open as possible to force the defendants to narrow the scope of the suit as it goes along, right? This isn't new to climate litigation. These issues were litigated in the MTBE litigation, for example. MTBE was a fuel additive that was designed to reduce oxygen content or to increase oxygen content in fuels, but it also tends to make a mess of groundwater. And so the courts had to deal with the same sorts of things. Whether do we have jurisdiction over the MTBE added just in our state or just in this county or next door? Does it matter what ship? And that's all stuff that has to get worked out. But that's all stuff that gets worked out in the course of litigation. The fact that those things are problematic and difficult have never before now been used as an argument for dismissing the cases on the front end, right? That the idea that you could dismiss the cases on the front end on those bases is something that was essentially invented in this litigation, or it's been tried a couple times, but it's never been successful. And the first time we've ever gotten any biting on that sort of thing has been in this litigation. But the reality is, right, Boulder presumably will have to show, okay, we have jurisdiction over this company and over this proportion of the company's activities and this proportion of emissions, and then they're going to have to show. And the more and more they have to do that, the more I think most of us in this room would say, yeah, like a court's going to think that can be shown with a preponderance of evidence. I mean, no, because it just becomes too speculative. But in our system, unless the legislature wants to come in and say enough is enough, we let plaintiffs try and make their case. And the history of environmental law is plaintiffs trying to make their cases, and some of them succeeding when people thought they were going to be wrong. And in retrospect, when we look back, we say, thank goodness, because that plaintiff actually recognized an environmental harm that the rest of the world was going to ignore. And thank goodness they brought a suit and helped to educate us and inform us. And if legislatures think that's leading to bad policy results, as we've heard lots about, legislatures remain free to do that. If David Bookbinder were here, he was originally going to be honest, he would make an argument that there are that some of the legislative solutions would produce takings. That's a fun argument, but that I'm not sure how far that would go. But as a realistic matter, right? Congress could tomorrow, if it wants, make all these cases go away. You know, why hasn't that legislation been introduced? Why isn't the president talking about the need for that legislation? Why aren't committees holding hearings on that legislation? Why aren't they doing their job? Why are they instead asking courts to play policymaker?
Yeah, I'll just add, I mean, one of the things that's interesting, one of the things that's interesting is how slick these theories are of these lawyers, right? They just kind of move from one theory to another. So, you know, the obvious point is, you know, on the policy thing is these are huge questions, complex trade-offs, cost benefits, all these different sorts of things. So, so what they've dressed up, one of their claims now is that this is just deceptive advertising, that it's like the cigarette cases where the tobacco companies refused to admit that their products were going to kill you. And for years and years, the petroleum companies refused to admit that they were, causing potholes in Boulder, and an equally horrible result from their products. And so they engaged in deception, right? I don't know whether this meant they could have also sued them in the 1970s on the theory that their products were causing global cooling, or whether if they had said at that point, that would now be a claim to say that it didn't cause global cooling, they actually caused global warming. But basically they've got this slick theory that says we don't need to worry about these trade-offs. We don't need to worry about the impact of people of Boulder because it's just false advertising. And if people had known this, they wouldn't have bought as much gas for their cars.
But even under that theory, I mean, if you and I probably both agree that the ability of Boulder to show that a meaningful proportion of the fossil fuels sold in Colorado would have been changed had Exxon said something different about climate change in 1987 or whatever. I mean, I think you and I are both incredibly skeptical they can show that.
Right.
But the fact that, in no other area do we say, just because a plaintiff has a theory that once we actually think seriously about it, seems crazy, therefore the Supreme Court is supposed to come in and dismiss it, right? There's no history of that. Rather, if we expect courts to play their role of filtering these sorts of things, and if they fail to, we expect legislatures to fix it. I just don't understand why in this one case, folks, and I should just note, Professor Zwicky was my professor in law school. But why
Todd,
in this one
how
area?
have you miseducated this
I know,
person
right.
so badly?
Why in
Come
this
on,
one area?
correct your student.
Folks who usually are like courts do law, legislatures legislate, are so willing to throw that out the window just because we have a Congress that's more interested in being on TV than it is in legislating.
I can't think of any situation like this. I mean, I can't think of any situation in American history where you had
The gun suits. The gun suits are a good example, right? I mean, the gun suits example is that you, when you sell a gun, you have to be able to, you're going to be held liable for the fact that some percentage of your customers are going to do bad things. And under traditional tort law principles, all these suits were nuts. And yet some plaintiff lawyers looked like they were going to get lucky. Some courts refused, allowed to hear these cases. And so what happened? Congress said, look, this is an organized campaign that's not about, in our judgment, about getting redress to actual victims. This is rather a campaign to subvert the Second Amendment and the right of people to own guns. And so we, Congress, are going to do something about it, because when courts get out of their lane, that is what we, the legislature, are supposed to do. So we have seen this.
Right. No, I disagree. I don't think Americans suing Americans for selling guns in America is at all like trying to affect the entire global economy.
But that's not what the suits. That's not what the suits
potentially,
are.
that's what the effects of
Let
these
the old
suits
man
are.
finish.
Yeah, that's what the effects of these suits are. These are, maybe that's stretching it, but we're talking about rearranging the entire global economy through litigation. I think that's definitely different from a pigsty in a residential neighborhood. And I think that's different from even the gun cases. Maybe gun cases stretch the point, and we're talking about questions of foreign affairs that Michael had. And I think we had a sensible understanding. If the understanding this is generally a federal question to deal with these sorts of things, that's a sensible way of dealing with this. That just strikes me as kind of is different in kind from most any other question I can that I can think about with implications and the ability to bring these repetitive nuisance suits over and over in all these different jurisdictions. That just strikes me as something different. So.
Yeah, and Jonathan, just to respond to your point about when have we done this before, going back to the beginning of the Republic, we've had a debate about what law applies. And we had federal common law, there was the Erie decision. After the Erie decision, obviously we have specialized federal common law. Justice Ginsburg talks about the keener understanding of specialized common law, and she puts environmental law clearly under there. So the question isn't, why don't they get to try the case? It's under what law? And they've chosen the wrong law. The right law is federal common. The cleaner understanding of federal common law puts these issues under federal law and then under the Clean Air Act.
So
and
Justice
there's a
Ginsburg says
long
the
history
opposite. She says at
of-
the end of her opinion, whether these cases, she says these cases were, AP was originally both filed under both federal common law and state law. The Second Circuit only decides the federal common law claim after sitting on the case for 2 years. Justice Sotomayor was never asked about that at her confirmation hearing, even though she was on the panel, but that's another issue. The Second Circuit decides the federal common law claim. That's what goes to the court. She says at the end of her opinion, whether the state law cases can proceed is a function of whether they were preempted by the Clean Air Act. And we know, given that the Clean Air Act's savings clause is even broader than the Clean Water Act's savings clause, that the state law claims, including for transboundary pollution, are therefore preserved. How do we know that? Because the Supreme Court said so in Ouellette, and we know what, in fact, what happened after Ouellette in terms of the litigation proceeding.
But I'm just going to quote this. She says, sought relief under state law, in particular, the law of each state where the defendants operate power plants, which is to say, she opens up a possibility to debate whether a state could bring a case under the law where the emissions happen,
No,
which
that's
is
not how that works. So the
the
International
law of
Paper,
each
International
states where
Paper
they
versus
operate.
Ouellette is actually a good example of this, right? So the case is brought, and it's going up to the Supreme Court effectively on the choice of law issue. Supreme Court says, okay, Vermont, you're going to have to sue this New York facility under New York law, and it now goes back to the court. It's the same case. It doesn't ever get dismissed. It doesn't get refiled. It's the exact same case, and now the lower court is just told, okay, when it gets to the question of which law to apply, which often comes up in the course of litigation, we're telling you what the answer is. So the same thing in these cases. Instead of trying to get them dismissed, the defendants could be saying, we want a ruling of, as a matter of law, what law is going to apply in what context, force a state court to say, if you want to reach emissions that occurred outside of Colorado, in the Boulder case, for example, you're going to have to look at the law of every state for the proportion of emissions you want to claim credit for. Get the court to rule, get the lower court to rule on that, or they just exclude those emissions from the case. The point is that in the way litigation is done, fine. Then the damages that they're asking for aren't Todd's nightmare scenario, but are actually only a tiny bit. The point is that we handle these things in litigation.
I'll add one
in
last
the more
sentence.
normal
There
way.
was no
We don't
federal
dismiss.
common law of guns.
Okay, we're over time. I was worried this panel would not be as exciting as the first panel. And so maybe for those of you who make it to the end, we'll have a massive panel where all the panels can argue with each other, which would be a lot of fun. I just want to make one last point, just stepping back. The lesson I draw here is either, regardless whether Jonathan's right or Todd and Mike are right, both of you are arguing for judges to make the policy in the end, because the Congress is not going to pass a law. And so it's really going to be, is it going to be state judges or is it going to be federal judges who make policy? And there's reasons to question whether either of them should, right? I think state judges, I'm a Berkeley person. We don't like state courts at all. And we sort of generally teach, we want the federal government to run everything. And we worry about the politicization of state judicial elections and so on. And but we also, right, this Supreme Court is really against judges making policy too, right? That's one of the lessons of the Roberts Court. But I just leave you that inevitably it sounds like it's going to be judges, whoever wins will make the policy on this question. And I want you all to ask yourselves, is that really the best policy-making outcome, to have state or federal judges make these decisions? So join me in thanking the panelists, and we'll take a 15-minute break.
I like your last point.
45.
this. We do have a reception after this panel where you can spend time chatting. Oh, and the wine is here? Okay.
Yeah, I got it in a room, so.
All right, we're between everyone and wine, so let's
I
go.
know.
So we're going to be fascinating and
Yeah.
keep them riveted.
Scintillating.
I probably still have too much, but that's all right. I'll cut it down.
You can cut it down. All right. Okay, everyone, welcome to the final panel of the day. My name is Linda Deno. I actually am not at the UC Berkeley Law School except as a fellow. I am actually at the University of Arizona, but I took it as a compliment. These days, it doesn't really matter. And I am moderating this panel today. I'm really excited to introduce two people that I had never met before today, and one person I've known for forever. I'm going to start with Jessica Winkle, who is Winkle. You told me that, and Jessica Winkle, who is associate professor at the Department of Public and International Affairs at the University of North Carolina, Wilmington. She is also a senior fellow at the Breakthrough Institute, where her latest contribution is a climate-related financial risk boondoggle, bad methods and conflicts of interest in the attempt to green finance. Her professional work focuses on environmental policy and coastal risk, and she writes on Substack. It's the Conflicted Substack, from which I drew a quote that I hope everyone can appreciate. I know I do. There's an old joke about why God couldn't get tenure. He only wrote one book. It was a long time ago, and it was pretty controversial. Furthermore, while it may be true that he created the world and everything in it, what's he done lately? Should I all three? Are you ready? Okay, then I'll keep introducing, and we'll give you a little more time. Next, we have Lynn Kiesling, who is an economist who focuses on regulation, market design, and the economics of digitization and innovation in the electricity industry. She is director of the Institute for Regulatory Law and Economics in the Center on Law, Business, and Economics, a faculty fellow in the Paula M. Trenans Institute for Sustainability and Energy, an adjunct professor in the Master of Science in Energy and Sustainability program, all of these at Northwestern University. She is also an external faculty member of the Santa Fe Institute, a non-resident senior fellow at the American Enterprise Institute. In addition to her academic work, she has served as member of the U.S. Department of Energy's Electricity Advisory Committee and member of the National Institute of Standards and Technology Smart Grid Advisory Committee, and an emerita member of the GridWise Architectural Council. In her free time, she occasionally shows up on podcasts like the DER Task Force podcast, which named her the Queen of Power Markets. And Steve Hayward, next to me, is visiting professor at Pepperdine University's School of Public Policy. He's a senior fellow of public law and public policy at UC Berkeley Law School. Among his 10 books is the Almanac of Environmental Trends, and the highlight of his acting career is An Inconvenient Truth or Convenient Fiction, which the New York Times called a point-by-PowerPoint rebuttal of former Vice President Al Gore's global warming documentary. Jessica.
Thanks, guys. Thanks for having me here. I'm very excited to be back here. Last time I was here, I was graduating with my bachelor's from the university, so it's cool to be here. All right, so I want to talk about the lessons that we can draw about democracy and scientific expertise in the wake of the collapse of climate change politics. And I think it's I don't know if it's a permanent collapse, but it's certainly a collapse over the past year. I've been asked about this a couple of times I studied under Roger Pielke. A lot of you guys follow him. This is part of something that we've been talking about for a long time. So if you follow his Substack, some of it might sound a little bit familiar. But I bring that up because so far I've had several questions about it. And yes, I do know him, and we continue to collaborate. So why should we care about experts and democracy? So the first part is we need experts in policymaking. We have a very technologically advanced society. Our systems are complex. We need good information. And the other part of it is that it's sort of a tradition of American politics is to be concerned about protecting policymaking from capture by the experts that we're working with. So there's a campaign, and this is sort of, I don't know, if there's still a climate change politics, this is where it's at right now. But think about the technical expertise you would need to make your way through what they're talking about. There's some interesting things that one could talk about whoshouldpay.org, but more specifically, the entire idea, what you're looking at. You're looking at an issue through the lens of climate change science, into insurance and all that is insurance technology and the business of insurance, and then into this idea of economic collapse. So to make your way through this, to engage with it effectively, you need to know about climate change science, you need to know about weather extremes, you need to know about disasters, you need to know about disaster losses, you need to know about insurance rate making, the structure of insurance, and then you would need to know about the economy. So it would help if you knew a little bit about real estate trends, real estate pricing trends. This is an incredible level of technological politics that you have to make your way through to engage with it effectively. Or technocratic politics, I'm sorry. And so that's where that stands. Real quick, I gather a lot of people know this, but the messaging on losses and disasters conflicts significantly with analytical understanding of losses, right? So basically advocacy messaging has been, look at all this climate change, you can see it in our disasters and you can see it in our losses, and then the analytics of it is more like, no, that's really just our expansion of our urban centers, our socioeconomics, we're wealthier. Maybe there's a little piece in there for climate change, but really it's just our changing social world. So that's the underlying knowledge about losses that is lost in this whole like climate risk thing. There's another piece to it, and it has to deal with the models. The idea that even though we know that the losses are a reflection of our societies, what is going on in the models that may be used in financial decisions, whether that's rate making or investments? Are we simply performing climate risk or climate change risk in our financial decision making? And by performing it, we're making it real in so much that you got to pay for it. This has been something that I've followed for a really long time. It came up earlier in 2005. There were some model changes in the reinsurance industry that made it salient then. Now we're seeing it again. But it's also starting to make headlines. So the coroner article is from a Wall Street Journal article focusing on some issues with Zillow and their use of a climate risk model and people's concerns that it's affecting real estate pricing. So when you move from this climate risk insurance issues to economic collapse, is it really a climate change thing, or is it actually an issue with how people are using models? And historically, right, so like, in fact, there was a concern with the global economic crisis around how people were using the models, gaming the models, providing a false sense of security. Okay. So modeled climate risk has turned into big business. Will it continue to be big business? I don't know, but right now it is, and it has been for a while. So this was a New York Times article from a week or a couple of weeks ago or whatever, saying that the financial industry has turned their back on this idea of climate risk. It seems to be pretty good, still going, but we'll see. Anyways, it's big business. It had started off, I would say with this big business, you're seeing, or I'm seeing a closer relationship between industry and research scientists, academic scientists. And this has been going on since the early 90s, where the reinsurance industry started funding academic research, primarily in hurricanes, but also wildfires, other stuff, and creating a relationship between academic researchers and industry. It was never I've argued, it's never been well acknowledged in the literature about these relationships. Over time, that grew, and certainly it grew a lot over the last 10 years when you started to see larger investment firms get involved in climate research. There's two messages around this. One is some sort of apocalyptic scenario where everything falls apart investment-wise, and we see the end of capitalism as we know it. And this is a guy involved with a German reinsurance firm. And then the other side is a lot of money. So this quote is from Fermat Capital's CEO. They deal with catastrophe bonds. This was from a couple of years ago where he's talking about, he's like, the media dynamic, the talking about climate change constantly, this idea of climate risk is making us a ton of money. And so the politics of climate change became also married to the investment activity around climate risk. There was earnings, from what I hear or what I understand, this level of earning is unheard of elsewhere in the market around catastrophe bonds. And then also property casualty is doing great as well over the last several years. At the same time as everybody's talking about all the climate risk. So there's a bit of in any sort of area of protracted policy making, there's a tendency to develop sub-governments, and a classic sub-government is the Iron Triangle, where basically you have the policymakers, mainly congressional committees, specific congressional committees, some sort of industry lobby, and a bureaucracy, the rule makers, all scratching each other's back, creating a very closed network of ideas. That is a problem for anybody else trying to access the agenda, trying to give new ideas, trying to give new ways of doing things. What holds that together is the social relationships and key ideas where everybody's got the same worldview, and that's what they're working towards. So I think it's important to consider the speed and scale at which things moved over the Biden administration. And this is not knocking any specific administration, but to actually consider what happened. So this is Brian Deese, Biden, and Gina McCarthy. And what you're seeing, Deese came into this position as an economic advisor to Biden, straight from the sustainability division from BlackRock. And then, of course, you had McCarthy, who came in from NRDC, and then prior to that, the EPA. Very quickly, you had several EOs, one which was, we're going to elevate our experts, right? Listen to the science. You had the scientific community, then you had the orientation of the government outlook being around a climate crisis, followed very quickly by a EO to organize the entire federal government around this idea of climate-related financial risk. And the broader heading of that being climate risk. Presidents strengthen iron triangles or weaken them. They don't necessarily get rid of them, but they can strengthen them or weaken them. Right here, you're seeing a very strong strengthening of the relationship that made climate risk happen over the last several years. The concept of climate risk doesn't originate in science. It originates, in my opinion, here with the Institutional Investors Summit on Climate Risk. It was organized by Ceres, which is it's an NGO that kind of creates a coalition of investor interests, where they started talking about how climate risk was a financial risk that needed better disclosures. They were going to start moving towards asking the SEC for better disclosures and encouraging investment firms to advance disclosures in climate risk. If you follow this concept and you say, okay, well, who's talking about climate risk in Congress? These are the top congressional committees. The first three, financial services in the House, banking, housing, and urban affairs in the Senate, are all dealing with financial institutions. And then you have appropriations, which is giving out money, right? So this is where climate risk, that concept, had come to root in these committees. If you consider who's the lobby then, your lobby is your major financial firms, which is not really all that surprising. But if you go look at, like, let's say, documents that claim to be dealing with the climate risk landscape, these are the people that they're talking about. And they're all they're investment firms and they're analytic firms. So they're selling the idea of climate risk. There's also an interesting advisory committee that was created to give information or expertise to the Financial Stability Oversight Committee underneath the Treasury. And they also had lobby, industry representation there, which makes sense, but. Right, so then you have the rulemaking. That's when you ended up with the SEC rule. You had the FSOC report coming out on climate risk. Federal Reserve System moves to engage this stuff in climate and bank stress testing. Federal Insurance Office gets involved. You start to see the movement with your rulemakers on this topic. So you have the triangle. What is classically important in the triangle are those experts. The experts that can move seamlessly between all the 3 points on the triangle, engaging with information, and holding together that conception of risk or conception of whatever it is. They can engage with the peer-reviewed literature, produce information that reinforces the worldview of the select interest, and they work among it. So this is in 1981 work on the Iron Triangle, the military-industrial complex. And he's talking about the role that advisors make, and that what ends up happening is alternative or public perspectives are absent, only a limited range of technical disagreement survives.
Jessica.
Yes. Oh, no. Okay.
2. Yeah.
Anyway, so if you look at the advisory group under the Financial Stability Oversight Council, if you look at those people, not only who they represent on paper, but then also their board memberships, right? You start to get these analytic groups that have advanced the idea of climate risk, extreme climate risk, and then also developed methodologies that preferred methodologies, emissions accounting and stuff like that, and the ways of disclosing. You also had the Sabine Center for Climate Change Law was represented, and you had some as part of university academics that are involved in all this, moving around. Okay. This gets rooted into your assessment reports over time, and then gets defended, right? So you have, it's kind of a long story of how it got rooted there, but it got rooted there. And then you have the experts moving around the triangle, engaged in producing the reports, producing the research for the reports, and it's all reinforcing. When things start to get challenged, particularly the scenarios, the emission scenarios. It became, over the last several years, there was really strong challenge to these scenarios. The White House stepped in and they said, we're going to give it legitimizing, we're going to give it a legitimizing argument. And they say, no, 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 don't look over there. Just keep doing what you're doing. You can keep using these scenarios. And so they keep reinforcing that triangle and the methodology. So this is a bigger deal than I think people give it credit for. There's been a growth in the financial industry's relationship with researchers that is significant, often in prominent places. Prominent researchers have significant roles or relationships with the financial industry. And there's all kind, or, you know, litigation as well. And there's all kinds of stuff that is not well represented in the literature or disclosed. What happens when there's undisclosed COI in research? Well, in the past, in medicine, there have been issues of serious misconduct and patient death, and Congress got involved in trying to better understand all that. But what happens in areas like climate change and economics? Nobody really dies, right? Like it's all dealing with predictions and projections and investments and stuff like that. But there are problems. There are clearly problems. Regulatory capture, which I just discussed, distortions in research trajectories. Climate has had such a large ranging effect on research in so many disciplines. And this is part of that. Loss of public trust and technocratic politics. And ultimately an undermining of good science advice. And then the lack of democratic inclusion. Nobody can access the agenda outside of this small group of people, and they're reinforcing ideas. So we fixed it, right? We got the chainsaw, we got the strongly worded EO, we got the report, we took our toys and went home, and then we said, okay, we're just gonna restructure the whole thing. I don't know if that fixed it, but it's definitely a long road ahead. The damage that has been done to the US research enterprise in a lot of different areas is significant. And my belief is very few people understand exactly what happened in climate. The relationship between that science and finance. The universities are just trying to hold on. Professors have no idea what's going on. US researchers, the ones that I interact with, they're disheartened. And there's a credibility issue. I think as far as the solidity around messaging. We tore it all down, but we don't have something that replaces it in the same way of the status quo kind of existing message that was there already. All right, thank you.
Okay, sorry. Do I have to wind it back to you? I didn't want to cut you off. I was really fascinated and realized.
Thank you. Interesting. Thank you. And thank you for inviting me. Now for something completely different. I'm going to talk about electricity. And in particular, I'm going to talk about electricity technology and markets. Because markets, as we know, are knowledge ecosystems that enable innovation. And I hope that through that path, I may, at the end, say a couple of things that connect to the topic of the first two panels, but maybe not. We'll find out. I've also written quite a bit on the Texas electricity model. So I always love talking about electricity in Texas. And so I'm glad to do that. And I am taking the title of the panel pretty seriously, the future of electricity in an AI-driven economy. And so I want to focus my focus to be essentially kind of bringing you up to date on what's going on in the US in terms of the use of electricity in data centers. Because as you might have heard, AI is the thing. And there are a lot of data centers and are forecast to be even more. And so that's going to be the focus of my attention. But one of the things that I do, I have a background in economic history, and so I think it's really important to start with some of the historical and theoretical fundamentals. And so when we talk about electricity, and I'm gonna have a couple of remarks here to say about its regulation, the status of electricity as a regulated industry. It's a good idea to start with the economics. One of the reasons why electricity is as heavily economically regulated by the state, and by state I mean state generally, but also at the state level and at the federal level, is because of the historical characteristics of the technologies and the implications of those technologies for the cost structure in the industry. And this shows up in two categories in economics: economies of scale and economies of scope. So economies of scale, I love to illustrate with this, the picture on the left. This is the turbine hall underneath Niagara Falls in 1895. And there's, I think, 24 of these turbines underneath Niagara Falls, because boy, is there a lot of force coming down that drop of water. If this guy standing next to this one is of average height in 1895, so about 5'8", I think the technical term for that machine is it's huge. And there's 24 of them. And so operating at that kind of scale was unprecedented in the late 19th century. This is one of the most massive and consequential contributions of innovation, was the ability to produce electricity at this scale. We also saw the economies of scale like this from railroads and telecom, but in electricity, it really showed up. The other characteristic that's important is economies of scope. I like this picture on the right because it's a very early picture of multimodal transportation. We have a horse-driven buggy, an old horse and buggy on the left, a horse-driven streetcar, an electric streetcar, and then right over in the right-hand side, you can see the little teeny corner of the wheel of an internal combustion engine-driven vehicle. So we've got all four modes of transportation. The electricity industry was founded in electric lighting. That was its product. It was going to produce lighting, and that was it. And then over time, through entrepreneurial thinking, mostly Sam Insel at Commonwealth Edison in Chicago, said, hey, you know what? If we electrify the transit during the day when we're not selling lighting, we can get a whole lot more utilization out of our existing generation capacity and make a ton more money. And so that's economies of scope, where you use one set of assets that one company owns to make two different types of products. You put these two together, you get the characteristic that in economics we call natural monopoly. Natural monopoly is where you have this downward sloping long-run average cost curve, which means the more you produce, the lower your cost per unit. And this was happened at an unprecedented scale in these railroad, telecom, electricity industries in the late 19th century. But this poses a problem. The problem, and this is especially a problem politically in the progressive era, because if the natural tendency of this cost structure is to become one firm, doesn't that just mean that this firm is going to, crank up prices, reduce output, and that would make consumers worse off? And so, of course, the argument was we need to regulate this industry so that doesn't happen, which is how we get to that purple dot, lowercase d. That is the sweet spot, which in theory is where, of course, the regulator, the omniscient, fully informed, not prone to any kind of capture or influence, is going to, in the public interest, get us to D. And that as a result, we will have a huge amount of consumer surplus. The regulated utility will be paid to recover their fixed and variable costs, including the opportunity cost of their capital, and we will just have a little teeny tiny bit of waste or deadweight loss. That's in theory. We all know, of course, in reality that that's a bit of a fiction, but that's the theory. So fast forward to today, right? And so we're fast forwarding now 120 years, right? So regulation of that sort really started in the States in 1907. And so fast forward a century, and the industry that we have today, both technologically and economically, and the economic context in which it sits, are very, very different from what we had a century ago. And I think one of the things that we are learning today is that regulation, especially in this industry, that regulation is more historically contingent and more technologically contingent than the progressive era reformers realized when they instituted this regulation. That we have all sorts of different new technologies, which I'll talk about more in a second. We've got an expanding breadth of state policy objectives to include environmental and affordability and reliability and economic growth, in addition to the safety and reliability that were the hallmark of electricity regulation over the 20th century. We have started over the past 30 years chipping away at bringing markets to bear to enable the flexibility that's required to benefit from all of these new technologies and the new dynamism that we've experienced over the past 30 years. Texas is, for me, the prototype of the use of markets in this beneficial way. But the details do really matter. One of the areas where even Texas has not done a great job is in enabling markets to have rules that emerge that allocate risk well. And so that's another thing that is a work in progress, I will say. And what's going on right now with data centers illustrates, it just encapsulates and illustrates all of this very fast-moving scenario, the fast-moving landscape that we inhabit right now. And so all of that was just to say, this is a very staid, slow-moving, small c conservative industry and its regulation. And we all of a sudden, because of the rate of change in digital technologies, and now when you throw AI on that with data centers, this is an unprecedented rate of change, and the industry and its regulation are having a really difficult time grappling with it, and it's producing a lot of tensions. Oop, some funkiness in my header, and in particular, so the landscape that I laid out for you going back to Niagara Falls is very much this picture in the red. The one-way road, the generator generates, and the vertically integrated monopoly utility, has a wires network, and then we, the end users at the end, flip the switch and the light goes on. But now we're in that green world where we have such a variety of both supply-related and demand-related technologies, whether it's different types of generation technologies, different ability to use our personal technologies to control and automate what goes on in terms of our energy consumption in the home. And in terms of my own research, how do we send prices to those devices and submit our bids to participate in markets to control what those devices do. So it's a very, very different technological landscape. And the future, the future that AI is contributing to is really, it's not springing like Athena out of the head of Zeus. It is being built on some digital structure that we've been putting in place over the past 20 years. But what I think the growth of AI illustrates the extent to which what used to just be done with electromechanical switches and dials and a person in a control room in the power system can now all be done and be automated at the edge of the grid. So when we talk about edge computing in digital networks, you should also think about edge computing as being an important phenomenon in power systems, in power networks. And that way we can use digital networks to connect to and enable autonomous control of all sorts of different kinds of supply and demand resources and entities, firms, businesses, homes, that are connected together in the power systems, in networks. And data centers just embody this, and are kind of accelerating this in a way that I think for those of us who work on questions of regulatory reform, this is in a way, call it a catalyst, call it the camel's nose under the tent. This is going to be a phenomenon that will lead to a lot of serious and deep rethinking of some of these fundamental century-plus old principles, assumptions on which the natural monopoly regulation of electric utilities is built. This is Google's data center in New Albany, Ohio, looking pretty slick from the aerial view. Data center power demand, the map, to look at the map, the blue dots, and they're scaled by size in terms of how many megawatts of electricity demand the data center will be using. The blue ones are ones that are already in operation. The yellow ones are ones that are planned. And so there are a few things to point out. Number one, we all know that Virginia is kind of, ground zero is Data Center Alley, as it's called. That there's a lot of growth also planned in South Carolina and Georgia, quite a bit around Chicago. But of course, we all want to look at Texas. Look at how much data center activity there is in Texas. So if you've been hearing about this locally, here's your evidence to support what's going on here. The big yellow one in West Texas there, that's Stargate, which I think is a gigawatt size plan, campus of data centers, but also Utah. So there's a lot of planned activity going on, and some forecasts suggest that data centers will lead to electricity demand doubling or even tripling, depending on whose forecast you believe, by 2030. And this is an industry, like I said, that plods along, and if you have a 3% growth rate per year, that's a big year. And so the idea of doubling or tripling by 2030, mind-blowing, right? Add to that the fact that this is the array of the existing forecasts for what data center demand is going to be in the US, from the EPRI forecasts, which are their scenarios are on the low end, BCG's is on the high end, and you have a range in between. And so notice the variety, and notice also how much growth we're looking at compared to the initial year in 2014. All of this is to say there is a lot of uncertainty here, and this isn't like risk where we know a probability distribution and we know that there's some probability that we're going to pick that ball out of the urn. This is what I would call Knightian uncertainty, where we don't even know what the probability distribution is because we've never been in this scenario before. And that's a very unsettling place for a large, capital-intensive, rate-regulated industry to be. That takes 5 to 10 years for them to build their capital-intensive infrastructure. And the mismatch of that with the 18 months that it takes to build and power up a data center if you can get the power. And so for that reason, the hallmarks of the conversation that we've been having in electricity economics and regulation have been, number one, as I've already alluded to, is regulation up to the task? Are regulated utilities up to the task? This is going to be an opportunity for us to rethink, and especially for those of us who would like to see more individual autonomy, individual decision-making, and the role of markets in the day-to-day lives of people. This shift away from regulation and towards markets, because regulation is going to have to really change. That's something that's very important. And the other part is the technology. And technology is really, when coupled with markets, is enabling what is becoming kind of the hallmark word that those of us who work in electricity economics these days are talking about. And Okay, Josh, say it with me. This is the F word, flexibility. This is all we can talk about is flexibility. Can that data center be flexible? Or is it just running all out, 8,760 hours a year because serving us those cat memes and serving us the caricatures of what we do in our job, which is, I think, the meme du jour from AI, that those are so valuable that we're just running all out to try to provide the AI services for people? Or are there ways that they can operate, that they can change their operation to use and can use what is some of the slack in power systems? And there is slack in power systems. The capacity utilization in transmission systems is below 50% on average. It's just one of the things that digital technologies are enabling us to do is to think more and to act more on the timing, that we can change the timing of when and how we coordinate. And so, of course, if you want to change the timing of when and how you coordinate and have that be technology enabled, we're talking markets. Right? This is an illustration from ERCOT, right, the Texas wholesale market, from August 20th of 2024. Y'all may remember it was a pretty hot week. These are the batteries that are participating in the ERCOT market. And the blue shows the hours, and that starts at midnight and goes to 11:59. The blue are the hours when the batteries are charging. And the red is the hours when the batteries are discharging. And of course, the height gives you the quantities. And so this is a brand new technology that over the past 5 years has become much more energy efficient, much more economical. So you get much more bang for the buck out of owning a battery than you did 5 years ago because the technology has improved that much. And so, these batteries are charging at night, discharging a little bit in the morning when people are taking showers and making coffee, charging again in the morning, and especially in the morning, what are they charging with? They're charging from the solar panels that have kicked on because it's now sunny out. And so during the day, the batteries are charging, and then what happens at 6 p.m. when the sun goes down? All those solar panels drop off, but what do the batteries do? The batteries kick on and get paid really, really well to serve us with the power to cook dinner, hang out with our kids, watch Netflix, do the things that we want to do. And yeah, make some cat memes, of course. All of which is to say that markets plus technologies and a variety of different technologies, right? Reliability of electric service is a portfolio idea. And so the technologies all are different, and that's beneficial. So this has some implications, and I'm going to end here. Digital technologies are transforming both the supply and demand in electricity and at various scales, from residential, sending, my ability for my thermostat to bid into a power market all the way up to data centers. But the pace of change is so fast that prediction is very difficult, and we are facing a lot of not just risk, but uncertainty, and having to make high capital intensive decisions in the face of that uncertainty. And this is going to mean that we are in a period of some dramatic regulatory change. And so those of us who work on markets and regulatory reform, we have an opportunity to make that argument. Because markets are decentralized coordinators and processes of error correction. So if you're in the face of such uncertainty, you're going to make some bad decisions and people are going to screw some stuff up. What do you want? You want to participate in processes of coordination that enable you to see the error, learn from the error, and have people who can maybe profit from the error. And that's what markets do for us. And again, Texas is a hallmark for this. And so I'm glad to share that idea with you today. And now I will lateral to Steve.
Well, thanks. I'm glad to be going after Lynn for reasons that will become apparent in due course. So I'm actually here in place of Mark Mills today, who had to drop out a few days ago when an illness came up in his family. I am no Mark Mills. No one is. So I'm going to do something different. I'm going to talk about the view from California a little bit. I am a Californian. It is nice to get out of California and visit America. And also I'm grateful to the Civitas Institute for the invitation to get drawn back more fully into energy policy, although I'm teaching it again after a 10-year hiatus. Most of the last 10 years I've spent doing conventional political science, a little bit of law, and actually the last panel inspired me to say if I was doing a chapter of a memoir, I'd say the last decade was from Erie to Erie and back again, which is I used to trace out things like pollution levels in Lake Erie over time, to then thinking about the Erie case referenced before, and now I'm back to pollution levels in Lake Erie again. Although, as I say, energy. And I'm always a little bashful to talk about Texas because Lynn literally wrote the book on Texas and knows 100 times more than I do. So I'm hoping she will correct me gently for my errors or omissions here, of which there will be many. So it's a fun thing to make comparisons between California and Texas. Some of them you know. Some of you may not know how really dramatic they are. I mean, everyone knows that you can in Texas get half the house, or twice the house for half the cost as you can in California. But I think it's actually worse than that. There's another statistic I like to point to that is more illustrative of the dysfunction of my home state, which is that Harris County, the home of the greater Houston metro area, has several times in the last few years, just Harris County, had more housing starts than the entire state of California. Now, some of those housing starts are Californians leaving. We're now up to, I think, 1.6 million people net have left the state now in the last 10 years. How do you take a state like California and make that many people want to leave? Is there any other sunny state where they're losing people? No, I don't think so. We're the champs at this. By the way, there is an irony here. I think it's really one of those cunning of history moments that the no growth movement really starts in the Bay Area about 50 years ago, hugely successful, spreads across the country. And now, if you're following this, we now have the YIMBY movement, which are progressives who are saying there's too much regulation. Now they're confused about it, but I never thought I would see this. And where did it start? It started in the Bay Area. So we've come full circle. And it's interesting that one of the leaders of this movement is the most radical left, a member of the California state legislature. Again, a comic novelist wouldn't think of this. You may know that California's unemployment rate is more than a full percentage point higher than the nation. It's one reason we're exporting people. Our poverty rate is the highest in the nation by a lot. California, do it this way. Texas spends about a third less per pupil in its public schools and gets much higher test scores than California students do, even though the demographics of the two states are about the same. And we, by one calculation, depends on how many homeless you think we are producing in California. We've spent $25 billion at least in the last 10 years. That's, again, depending on how many you think, it's over $125,000 per homeless person, yet it keeps going up. I may say a thing or two about gasoline prices, although maybe not. I come to Texas and I look at the pump and say, is that for a half gallon? Is that really for a gallon, right? And then finally, California can't build anything, or not much, or with great difficulty and expense. I'll just give you two examples. One is, we passed 12 years ago a bond measure to expand water supplies, including the first reservoir in more than 50 years. That was 12 years ago. Construction is expected to begin finally next year. And none of the projects this bond is funding are expected to come online before 2029. But my favorite is back in 2018, Los Angeles County voters approved a half-cent sales tax for transportation improvements in the county. And it included a $365 million 8-mile bike lane along the Los Angeles River. Now, if you've been to LA, the Los Angeles River is not the San Antonio Riverwalk. It's a concrete storm drain channel. It was supposed to be open last year. You will not be surprised to hear that construction has not yet begun, and the total all-in cost is now estimated at more than $1 billion for an 8-mile bike lane. I don't know how this is possible, except in California where genius is. I could go on with all of that. Now, this led to the Atlantic Monthly about 3 weeks ago, an article written by one of their most progressive staff writers saying, California's progressive policies seem to have been reverse engineered from Republican Party attack ads. So that's how crazy things are.
There is one area where a lot of people in California, especially energy geeks, envy Texas, and that is in energy. So, the big issue these days is we're worried about electricity prices going up, right? I think the general trend looks like this. This is unadjusted for inflation, which is important, but it's that little, if I got the thing, it's a little tail up there to the right. You can all see it and make it out. If you followed the last election campaign, affordability of electricity was a big issue in New Jersey, I guess in Virginia as well, although their rates are actually kind of average. And one question to ask is this really a California story? In other words, one of my go-to persons on energy out in California, well, the individual in particular, Severin Borenstein, who runs the Energy Institute at the Haas Business School at Berkeley, also relied upon heavily by the California Energy Commission for analysis. He thinks it's a California story and that we're pulling up the whole national average. He offers this chart, which is inflation adjusted, so it doesn't quite match up with the last one, but the bottom line is the nation as a whole, and the top line is California. Doesn't look like a big spread, but to unravel this, we have to get into the way electricity markets work, and that's why I keep Lynn around, because I really hate doing it, because I feel like the unfortunate monkey who, once you get into this, you want to kill yourself. But if you do it more graphically, here's one map that's been popular, and you see California and the Northeast have the highest rates. Or I think this one's a little better. This is percent increases, which shows California in the last 6 years, 39% increase in electricity rates. Texas, 7% over the same time, right? The average price, according to EIA from 2 years ago, Energy Information Administration, 27 cents a kilowatt hour in California, 9.8 cents a kilowatt hour in Texas. And I know Lynn knows this, maybe Texans here know this. Peak demand in Texas is 3 times peak demand in California. So, hottest days of the year in California. And by the way, the California peak demand level has been flat for the last 10, 15 years. I'm not sure the trends are here. I haven't looked them up, but
Doubled in 5 years.
Has it?
Is that right, Josh?
Oh, yeah, that probably sounds, just seeing those data, we're not building a lot of data centers in California. We can, talk about that some if we want. Now, Lynn mentioned batteries. I'm really glad she did, because I am also. One thing is that California, we are building, not manufacturing the batteries, but boy, we are installing them fast. And you can see here that battery storage, California, we're clobbering Texas 2-1. And we're getting some similar results to the ones Lynn showed you, although I'm going to present it in a somewhat different way than she did. But then what does Texas have over California? Wind power. So here's wind and solar together for the 2 states. And California actually hasn't really added much wind capacity at all for the last 10 years. It's all been solar. Texas has gone crazy with wind. Now, there are a lot of reasons for that, which, again, Lynn knows better than I do, but I think having your own grid here under ERCOT, which has its pluses and minuses, actually makes it easier to integrate all these resources, right? That's one reason for it. The other one is, it's been a while since I've done this, but Texas decided to do the renewable portfolio standard game differently than most other states. Most states have a percentage target. We want 20% renewables by X year, 30% by Y year, 50% by Z year, and so forth. Texas instead did a numerical target for how many gigawatts of new renewable power they wanted. Now, I've always thought that my hypothesis is to play all this out in great detail. And again, Lynn could teach me this in an hour, maybe if I was paying close attention. I've got to think this changes the decision-making of people based on sensible things like, the cost of capital. I think it changes how those calculations that are so contentious about the levelized cost of electricity come out, as opposed to doing percentage mandates where you're trying to satisfy a regulatory target, which might not necessarily actually match up with actual power produced. Okay. Now, is this what I'm up to? No, I'm going to skip over that because I think my Texas numbers are wrong. Doesn't matter. So, Duck, if you're really an energy geek in California, Lynn knows what's coming, don't you? You're all about the duck curve. And normally I don't like to show charts like this because it's just busy, spaghetti straps and all. I like the simple ones. But this one's very popular. We call it the duck curve because what it represents is total power demand with wind and solar and other renewables, but mostly wind and solar backed out of it. And you can see that middle of the day, we get a lot of production of wind and solar power, so much so that we have a surplus in the middle of the day. This is from, this is a 8-year period. And every year that the duck's belly gets a little bit lower. Coming soon, maybe to a Texas near you. I'm not sure where it all lays out yet. And I like to show a different version of what's happening here that tracks with what Lynn did. And this is now almost 2 years old, but here's the generation profile, 30th of April, 2024. And what you can see is the big solar bulge in the middle. Because boy, we've been putting in the solar power and also the batteries. And I think what's important is not only the solar bubble there, but to the right of it, you see in the green, the battery discharge. Here's what Lynn was also showing you for Texas, right? But what's happening there in this chart is a couple things. One is you still see that we're running natural gas and wind in the middle of the day, but nobody's much making any money at that time. And something's missing from the power supply here, and it's Diablo Canyon, our nuclear power plant, which still provides on an annual basis about 10% of California's total electricity output in the state. But of course, middle of April, middle of October, that's it's true everywhere, right? Here in Texas too. It's the best weather, and that's when Diablo Canyon goes offline twice a year for maintenance and so forth. By the way, I predicted the day they announced 8 or 9 years ago that Diablo Canyon would close, I predicted they're going to reverse that decision. And they did. That's been an interesting story to follow. The diehard local, I live near Diablo Canyon, by the way. All my electricity is carbon free. I just claim that, even though that's not how it works, I know. But the local environmental groups are still filing lawsuit after lawsuit to try and stop its relicensing and not getting very far with it. But the diehards are still out against it. The other thing to know about California is the real unpredictable power supply every year is our hydropower. We've got a lot of that, and the amount produced every year by California's hydropower can vary by about 3x, depending on how much rainfall we've had. So in drought years, we don't get very much. In good years, we get a lot. And so that's very good for flexibility of systems, right? This year, actually right now, for the first time in 25 years, all of California is out of drought conditions of any kind, even stage 1 or however they measure these things. And it's still only February, so we'll see. All the reservoirs are full to overflowing right now. So it's a good year for hydropower, and that changes the prices a bit. Now let's see. But one of the things that's happening when you have the surplus of solar power and wind, if it's going on a good day, is our curtailments are growing, and this is just wind and solar being taken offline. You could say we don't have enough batteries to charge, but we seem to be putting in solar power faster than we're putting in the batteries to soak it up. I think I don't have to do the math on all that. And I want to go back to Severin Borenstein's calculations on why California's electricity rates then are 3 times higher than Texas. Well, one clue is from this article from the fall that maybe a few of you saw in the Electricity Journal. It was by the Lawrence Berkeley lab, not Borenstein's outfit at the Haas Business School, but they overlap together. And a complicated regression model, lots of caveats about data limitations and so forth. But it said something quite important, that what's happening is behind the meter, that's the phrase that's grown up in the last few years, behind the meter solar systems are cost shifting, especially in California. And one of the things that's driving this is California almost 10 years ago mandated that all new housing had to have solar power systems installed in them, which runs up the cost of new housing and apartments and so forth. And it also said here that they said generally in the study, it's in the highlighted part I put there in the abstract, is that states that did not have as rigid renewable power standards, absorbed more solar and wind without as much price increases or cost shifting. Again, the hypothesis there is that those decisions were driven more by conventional calculations of power providers and utilities about what made the most sense in conventional finance terms. That's my hypothesis. Again, you'd have to unravel this and hope you last longer than the monkey who kills himself. So in California, it's really quite stark how rapidly and dramatically the cost shifting has happened from people who have their solar systems. Borenstein has figured out that the three major utilities, PG&E, SCE, and San Diego Gas and Electric, of the three species of I like to call corporate socialists, PG&E is the worst. Although San Diego Gas and Electric has the highest rates per kilowatt hour. And guess what? That region of the state has the highest penetration of rooftop solar. I think, yeah, here we are. Here's residential consumption is over 30% in the San Diego region, which is quite a lot. And so we can now make out the correlation there. Let's see, what else did he have? Here's the cost shift. Borenstein thinks on the residential level it's as much as $4 billion a year. It's difficult to figure out to the extent to which the cost shift goes to, how much goes to residential and how much goes to commercial and industrial. He thinks it's about 70% to residential, but there's disagreement about all of that. Now, let's see here, maybe like 2 minutes left. Two quick things then. I'm going to skip the Rosenfeld effect, which goes back to the days when people talked about negawatts, and that's a fun story, but leave that for another time. There's the NERC map from recently about this is what grids they think are at risk of disruptions and instability in the next 4 years. You notice California is not on it, whereas Texas is, and a lot of other parts of the country. A lot could be said about that. But the last thing I think I'll do is this. So this is the kind of chart that I will show to students and ask them what's wrong with it. Not that it's false or completely wrong, but you just do I heard the claim, and then I saw this chart that California has, since the object of all these policies is decarbonization, and then I saw the claim that California hasn't decarbonized any faster or slower than the rest of the country. And to the extent this is true, one reason is half of California's energy is fuel for transport, and that's not going down at all. And we tend to be loading all of our efforts on electricity in so much of the country. Now, we're trying to make up with that with high gasoline prices, that are extensively taxed and regulated. As I like to say, that's for a lot of people in California, that's not a bug, that's a feature. But I'll leave that aside for now. But here, if you just do a percent reduction, it's the old mathematical or statistical trick where, someone drowns in a lake that averages 2 feet deep. If your baseline is measured on a percent, you may get some area that has more effort, greater baseline starting out with it. And so these numbers, although they're illustrative, I'm asking my graduate students actually to calculate these decarbonization rates with several other different ways of doing it. So for example, I started looking this around 2010, and California, let's go back to 2005, and then I'll stop. 2005, which was the peak of the nation's greenhouse gas emissions on a per capita basis, it was about 20 tons per person in round numbers. California was 13 tons per person. That's because of our climate. That's because of California's deindustrialization. So you're starting sort of different levels, and when you start doing it just by a percentage basis of overall emissions, it may not be the complete picture. Let's see, what was the last point about that? I've kind of forgotten, but I think I'll just stop there and skip over my gasoline torture horror stories and then go for questions. Yeah, thanks.
I'm going to actually ask the first question, and I hope ties all of this together. And it's actually about the politics of affordability.
Oh.
So, all of the reasons why people are moving out of California, but some of the problems with affordability, I think, are nationwide, and one of those, of course, is the cost of homeowners insurance. I can tell you that
At my household, it's a daily thing. Oh, my escrow payment just went up because the damn house insurance went up and I haven't paid it, you know. So we're all familiar with that, but that does actually make it very difficult for young people to buy a house knowing what it's going to cost them in homeowners insurance, what it's going to cost them to run that household with energy and so on. So I want to ask Jessica, and then I'll open it up for other people. Out of the whole big picture that you presented, do you see any actual policy differences in the affordability of homeowners insurance? If that iron triangle has been somewhat taken apart, is that a fair question? Are you following me?
Yeah, I would say so. The public's struggle with homeowners insurance dates back, at least in my view, it dates back at least to the 60s, where there were reoccurring instabilities by price changes that led the states to grow their residual markets. That whole history is kind of washed over as people have been talking about climate. And I think I would even say that there has been some very good conversations coming out from the circles that are more oriented towards climate advocacy and using insurance to make that case, where they're saying, oh, well, we can fix it this way, we can fix it that way. That's great, but they latch on to the climate change issue, which kind of makes it false, even if they have a great idea. So the problem is that the two issues, the affordability matter needs to be separated from the climate matter. And the affordability insurance issue seems to be something that deserves better critical engagement with from policymakers. But for whatever reason, they feel not so moved to do it unless it's latched onto the climate issue, and then you have a select group that's interested in doing it. So, but what I guess what I would say is the issue that we're facing with insurance, which comes and goes in the public's consciousness depending on like what's going on with pricing, has been going on for a long time. And it's in part, I believe, it's related to the way the homeowners insurance package was delivered at a discounted price in the very beginning in 1950. So what they said is like, we're trying to make this policy that gets married with our interest in growing the economy with mortgages. We're going to create this like discounted package, the homeowners insurance package. The bank said, okay, banks in 38 said, in order to have homeowners insurance, you need to have certain coverages. Those coverages got wrapped into homeowners, and now in order to get a mortgage, you need homeowners. So the affordability of insurance became tied to getting a house, and then it became like economic policy. So the whole thing goes like way back, but we only talk about it like in a very, we only look at it as a very short time scale discussion.
I have a very cynical, simple view, which is the affordability of homeowners, home and casualty, auto insurance, workers' comp varies from state to state in inverse proportion to the strength of the trial bar in that individual state. Not entirely true, but Florida has had a big problem first with homeowners insurance rates here the last few years and auto insurance rates, and the legislature got after it because they don't like trial lawyers very much, I think, and rates have come way down. But then, yeah, you throw in the climate overlay. I know I'm overly cynical and this is oversimplistic and hyperbole, but I always thought a lot of the insurers thought, climate change is a great thing to throw into the regulatory mix to justify a higher rate. And so regardless of how serious you think how it all plays out in the actual numbers of it, I thought how convenient. And I thought competition will eventually wear that down. And again, that would be a detailed inquiry, but that's all. I always thought the marketplace would catch up to that and discipline it to some extent.
Do we have any questions? Yes.
Well, you're supposed to wait for a microphone, remember?
He's coming.
Yeah.
He's coming.
Maybe a few things. So the first one, very often when I participate in this type of talks, specifically energy, people tend to avoid nuclear, and they don't include that in the equation of energy. And to me, I challenge and question the reliability of the information that I'm consuming, because if we say we trust in research and evidence, a lot of people have said that we cannot move on to tripling energy capacity without the help of nuclear. So is nuclear even in your mind? What do you think about it? And also, since I have not heard anything that relates to the topic of rethinking energy, climate strategy, or in a AI-driven economic, can you please give just one bullet point on what we can do regarding those two things? Innovation in energy and also climate strategy for AI-driven economic.
I'll take the first one since I think I talked to the second one in my remarks. Nuclear is, I think, absolutely part of our future, and there's a lot of innovation going on, both institutional innovation in terms of rethinking the regulatory landscape, as well as the technological innovation. And so, there are new reactor designs that are coming out of research labs and out of universities all the time. Whether or not they actually pan out and are commercializable is that's the big hurdle. And that's where some of, I think, the micro reactors are now, and the SMRs are probably going to be there within the next year or so. The standard kind of large scale light water reactor, Westinghouse AP1000 reactor design that we have now, that was done at very, very, very much over budget in Vogtle in Georgia, is still, if you were able to wrap that technology around a stable, well-trained workforce that can actually work on nuclear and can get like steady employment in the US, then that would help bring the costs down. And yeah, so I think nuclear is certainly part of this. And with respect to the data centers, all the hyperscalers have some kind of investment partnership with some form or another of a nuclear, from a either well-established to startup. So like Microsoft is doing things in Wyoming with Terra Energy. Google has an investment partnership. I can't remember the name of the company, but so nuclear is definitely part of the pipeline, but it's bigger and takes longer and it's more expensive. And so, figuring that out is really tricky.
I don't know.
Oh, what a frustrating topic. I actually know the person. Oh, well, I'll put it this way. I said that I never thought I'd live long enough to see progressive YIMBYs, saying we overregulate housing. The other one is environmentalists who say now are pro-nuclear power. So I actually know the person who he persuaded Governor Newsom to change his mind on Diablo Canyon and go to great expense to keep it open. And this guy's a lifelong environmentalist, about my age, and he said, yeah, the single biggest mistake in my career was opposing nuclear power when I was 25 and, marching in protest. So that's a huge change. It means, I think, that you will not face the political obstacles. There may still be litigation stuff. But then the other thing is, I've got a data series that shows that China's building, 25 reactors now? It's a big number. And their costs are a fraction of ours or other people that. Now, are those figures true? I always worry about Chinese data, but I don't know. I think it's the scale thing. I hear all the enthusiasm for small modular reactors. I hope it's right. I don't have enough expertise to judge it, but it seems to me that we may see, I never thought I'd hear this, and suddenly here we are, and it happened really fast. So that ought to be encouraging, I think.
I was going to give a whirl. So I was talking to a couple of people earlier today, and we were talking about the history that you need to give, and this is just life, right? Like the state of our policies are such that in order to explain now to the new generation of students why things are the way they are, requires like this whole discussion about, you know, post World War II decision making and going on and on. And so the other day, I'm teaching a 200 level environmental politics class, and I don't remember what it was that I gave them to read, but it was something. And then I was like, you know, 350.org, and it was blank stares everywhere. And I was like, oh, wow. So like this whole discussion of like how we got here on climate and what to do next, the level of unpacking that's now required to discuss what happened is a lot. And I don't know what you do about that. I don't know. I guess the answer of like how this is all going to unfold going forward. But it's been a long journey. It's been a complicated one. I'd also say that even though they didn't know of these like main players from that sort of founded the whole movement, the heuristics are there. The constant moving back to like, they delayed action. The only reason that we don't have different energy is because they didn't want to do it. It was the fossil fuel industry. Like the disasters are getting worse because of climate change. So like, even though the climate change is not necessarily the most important thing that they're thinking about, and they don't necessarily know the history of the movement, the heuristics are all there and they're deeply embedded. And so how do you deal with all that without having to give somebody a 101 on like everything that happened since, you know, 1987, is hard. I'm not really quite sure what to do. There's a question.
Wait for the mic, I think they're telling us, because they're, you know.
It's being recorded, so.
Yeah, sorry.
So in theory, I would say nuclear sounds reasonable, but in practice, it's been horrible. And where would you propose building the nuclear waste site? Not too many states want it, but it's right now you're storing it on site. I don't think that's long term. And then plus, if China's so good at it, maybe you want Chinese wages?
Well, I don't know. Yeah, I mean, well, we did build a nuclear waste site in Nevada until the political class there. By the way, my in-laws are from Nevada. I've been there for 75 years. They all wanted it in their backyard. So I don't know. The big decision there is, are we going to decide to reprocess fuel or not? Because then it shrinks from a pretty small amount to a really tiny amount. We've always been against that for nuclear proliferation reasons. I understand that in the abstract, but nobody else is eschewing reprocessing. Everybody else does it. So that genie is out of the bottle. So it becomes a much tinier problem if we do that. So that's one part of it. I'm not sure how the Chinese are doing it. I'll keep up with that.
I think one last question we had here.
Thank you. This question is really about Texas. So everything being built is wind, solar, batteries. The Texas Energy Fund has been largely a failure. And how do we keep prices low without a capacity market in Texas? How does thermal generation ever really show up?
I'm trying to think of how spicy to make my answer to this.
Oh, go all the way.
Given that we're going into having cocktails. So one question might be, and I will say this just because in the things that I've published and been a co-author on with respect to Texas, especially post Uri, I've been very critical of the legislature's actions. And I think that, and even longer than that, and for like the past 20 some odd years, I've been very critical of wholesale power market designs that involve forward capacity mechanisms. And one of the things that ERCOT does really well, and the other wholesale power markets in the US do very badly, is deal with relative scarcity. And none of them do it perfectly. And I think if you really peel back the onion to the main determining factor, it's the price caps, right? That we just do not have the political guts to let prices do their job. And Texas has had a high price cap. When Uri happened, that price cap was controversial and brought down. But even before that, they had the operating reserve demand curve, the ORDC, that was kind of a bolt-on, administratively determined way to deal with, what happens when prices get high. How do you get the higher cost, but at the time high value generation to come to the market? And that's the real problem with that capacity mechanism. Forward capacity mechanisms are supposed to solve. Other states, in particular PJM in the Mid-Atlantic, has shown that they don't do that. And so I would say that I would avoid capacity mechanisms because they don't do what they say on the tin. And so my spicy question back is challenging the premise that we need thermal generation, right? Do we need thermal generation? And in particular, this is, and I apologize because you really picked on one of my pet peeves. So I apologize, but this is an industry where we talk about capacity all the time. And now that these technologies are so heterogeneous, I don't care how big you are. I care what you can do for me. And so I think we should shift from talking about capacity to talking about capabilities. And so if you have a well-structured enough portfolio of different markets, a day ahead energy market, an hourly energy market, a 15-minute energy market, all your ancillary services, reg up, reg down, all the, and you specify and you say, okay, I'm going to show up. Here's my bid. Here's what I say I'm going to do. And then if you don't do it, you penalize the bejesus out of them, right? And I think that's much better than these forward capacity mechanisms, and also more technology agnostic, because I think one thing that has been unproductive in the past 5 years since Uri is the lack of technology agnosticism and all the blaming and finger pointing.
Is the wiki still here, or did that rat leave? At the last panel, he clearly has a Jones for Tom Steyer. Okay, Steyer's running for governor, and he's blanketing the TV with ads right now saying that the main thing he's going to do is make the utilities lower electricity costs by 25%. And that's when I said, I got to call Lynn, man. I mean, somebody remind California, how did it work out 25 years ago when we tried price caps on the utilities and we had rolling blackouts? Oh, that worked really well. Let's go back to that. Right. Or not, right? I think,
or not.
Okay.
Or not.
But that's the answer that we're being given.
I think we're out of time, folks. Can we give this panel a hand? You know what we didn't very interesting was resiliency.
True, although it's implicit.